Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about PLC GE and GE software, Proficy Machine Edition and Proficy Simplicity Workbench about how to create alarm sound. Okay. In this section, I will use the GE controller, CPU IC 695, CPU 310, and here is the Ethernet module, and here is the power supply. Okay. I will connect from Ethernet module to my computer via LAN cable, and I will use the software Proficy Machine Edition version 9.5 to create a new program for a sound system, and I will use one more software for create the sound alarm, Proficy Simplicity Workbench. Okay. So the concept is when I turn on M1, the Q1 is turned on, and then it will sound Q1 is turned on, or percent Q1 is turned on. Okay. So let's go to our software to configure the alarm class and the project of PLC to test. Okay, so let's go. So before we create the sound system, please remember we need to have the sound before we create the project. And right now I already prepare the sound. Yeah, for example. Okay, I will open the speaker. Okay, let me test sound. Yeah, this is a sound that we will convert if we have MP3 or MP4, so we can convert to dot wave. Okay, dot WAV. It support only this format. Okay, so make sure we have the sound that convert to wave sound or dot WAV. Okay, and here is the sound that I already convert. Yeah, and let's test. Example, input percent I1 is turned on. This one.
Input percent I1 is turned on.
This one, input percent I2 is turned on.
Input percent I2 is turned on.
Input 1.
Input I1 is turned on.
Output.
Output percent Q1 is turned on. Output percent Q2 is turned on.
Okay. So this is a sound, for example, that I will show to everyone after we create the project. Okay. So the first time we need to have the prepare the sound that already convert to dot WAV. Okay. So let's go to Proficy Machine Edition to create the new project of PLC. So double click and then continue. Yes. Okay. So let's right click on my computer and create the new project. Yes. And then example sound. Yes, sound system. And create the empty project. Yes. And I will use the GE Intelligent Platform Controller Air 3i, yes. So click it. Okay, it is the target name. Example sound system, yes. And we need to create the hardware configuration, right? Okay. So to create the hardware configuration, let's see here. The first one is power supply PSD040. The second one is the CPU 310, and the third one is the ETM. Sorry, it is ETM. ETM 001. Yes. And here is the MAC address that we will use this one for create the temporary IP. Yes. So please remember. Okay, the first one is power supply. So this one is AC. So I need to replace to DC, right? So replace the module, and this nameplate. Yes. The serial number. So IC 695 PSD040. Okay. And for slot number 1 is the CPU, right? So I need to replace the module. So we use CPU 310. Yes. So click on it, and then yes. Yes. And we need to setting the CPU parameter, right? So let's go to tab setting, and then I will change this one to always plus. Yes. For power mode, I will run the CPU. Yes. And let's go to memory. Yeah. For memory, we can set analog input, analog output, %R, %W, and I/O discrete. Yeah, example like this. Yes. So that's all. And then we go to slot number 3, right? So slot number 3 is the ETM, yeah, Ethernet module. Yes. So we need to create the Ethernet module for slot number 3. Yeah, here right click and then add the module. And let's go to communication tab, and then go to IC 695 ETM 001. Okay, Internet interface module. And then we need to set the IP address, right? So example 192.168.0.2000. Sorry, 200. Subnet mask 255.255.255.0. Okay. And for variable mode, we need to set true because we no need to use the reference any reference address. So click true. Yes. And then we can type example node 01 slot 03 ETM, and we need 80 bits, right, for this module. Yes, from I1 to I80, right? Okay. If we put like this, let's see here, the reference address is not used another %I. Example %I1, %I2 is not used. Okay. So that's all, and then go to set temporary IP, right? Because right now we cannot ping, yes, 192.168.0.200. Okay, we cannot ping from our computer to the PLC via Ethernet module slot number 3, right? So we need to set the temporary IP, but before set the temporary IP, make sure that we run as administrator for the software. The second, we turn off any firewall, example window firewall. Yes, we need to turn off here. So we need to turn off the window firewall. Yes, otherwise we cannot set the temporary IP, and we cannot connect to the PLC via Ethernet module. Okay. So the third one should be check, make sure that we manual the IP4. Yeah. Right now for my computer is manual mode 192.168.0.55. Yes. Okay. And then we go to target. Yeah. Click and then property. And then scroll to find the physical port, and then select the Ethernet module. Yes, Ethernet, and then type the IP address that we want. So 192.168.0.200, right? Okay. Okay, and then let's remember the MAC address that stick on the ETM. So 00099 E137. Okay, so we need to remember this one. So right click and then go to the set offline command, and then go to set temporary IP address. Okay, again right click and then go to offline command, and then set temporary IP address. Okay, and this is the MAC address that stick on the Ethernet module. So 00099 E1, yes, E1, and then which number? E1 and 37, right? So 37. Yeah. And here is the IP address that we will put here. So 192.168.0.200, right? To match with the IP address that we already set on ETM. Yes. After that, please click set IP. Yes. And make sure we already connected the LAN cable to the PLC from our PC. Okay. And then click OK. Yes, and wait a moment for processing of setting the IP address. Yes. So wait a moment. Reply like this, it means that we cannot set the temporary IP. So let's try again. Okay, it's so like this, it means that we can set the IP address successfully. Yes, and then we can exit, and then we can ping again. Yes, So 192.168.0.200. Okay. Okay, right now it reply. We can set the temporary IP. Okay, so we can link and then we can go online. Yes, yes. Okay, go online and then we can download. Yes, and download hardware. Yes, and then we can start. To start the CPU, we have two options. The first one we can start from here, and the second one we can start from the switch on CPU hardware. So right now I will turn on from the switch of CPU hardware first. Okay, let me show. So we can open the cover. Right now the CPU is stopped, right? The run LED is not shown. So we can open the cover and then select to run mode. Yes. So right now the CPU is running. Yes. And then we can check here. The CPU is run also, right? Let's see here. Run enable, config equal, logic equal. Okay. So we can switch run and stop from the CPU hardware. And the second one we can stop and start from here also by press this button and then we can stop and freeze the start and we can start. Yes. Okay. So right now we already successfully configured the hardware configuration for this system, and we will continue to create the alarm sound, right? Okay, so the first one I need to sound the output %Q1 is turned on, this one.
Output %Q1 is turned on.
Okay, and the second one I need to show the
Output
%Q2
is turned on.
Okay, so let's go to our program. Yes, and then I will outline first and then go to main program. Yes, so we can comment output %Q1 is turned on. Okay, turn on, then sound to simplicity HMI Workbench. Okay, like this, and we can create example. I use NO. Yes. Example, I use %M1. Yes. And then I will use coil. Okay, I will adjust a little bit. Yes. Okay. So input %M1 and then start %Q1, right? Okay. And this one we can select and then copy paste this one for Q2, right? Okay, so example %M2 turn on %Q2, right? Sorry, %Q2, right? Okay, so when I push %M1, it will turn on %Q1 and then have sound in the simplicity HMI, right? The %M2 and %Q2 is the same. So let's download the logic to the PLC, yes. Okay, so that's all. So we need to create the project of Proficy Simplicity HMI, right? For link from this one to the sound, okay? So let's go to Workbench, yes. And then we need to create the new project, right? Okay, I will create a new project. Example, go to file and then go to new and then project, yes. And we need to put the username and password of this project also, right? So example, I will use administrator and then the password, example, yes, we can put another password that we want. Yes, and then click next. And let's go to project name. Yeah, example, I will put sound. Yes, project name is sound. And then I will browse to dry C. Yes, go to dry C, and then I will choose the part there, the part that I will use. So I will use simplex, yes, this one, triplex, yes, and then create. So this is a project property, project description, so we can mention any command. Example, create the sound system, yes, and then let's click OK first, yes, and we need to add the alarm, right? Configure the alarm to sound the signal from the Proficy machine edition, right? It means that if I turn on this one, it will turn on this one and then have sound in this software, right? So the first one, let's go to alarm, yes, and then go to alarm class and right click and then create the new alarm, yes. Example, alarm name or class ID, example, the class ID, yes. So example, Q1, yeah, like this. We can put another class ID that we want, but not so long, yes. And let's go to audio, yes, audio that we want to sound, yeah. So click the audio tab and then go to the WAV file, yeah, that I already present. It support only diff file and WAV file, yes. So the file name, we can browse to find the file that I already put in the desktop, yes. So let's go to browse and then go to desktop and go to the sound folder, and then we can use this sound, right? So double click, yeah. So the file will link to the desktop, yes, and then click OK. and we need to create the point. Yes, it means that create the tag that link from the Proficy machine edition, right? So I will create the point, the new point. So to create the new point, right click on point tab and then right click and then create new. Yes, example sound 1. Yes, sound Q1, and I will use the device, right? So before create the device, we need to create the part first, right? So let me create the part. Go to part tab and then right click and new part. So we will use the S9T. Yes, triplet, and start from part 0, and here we can use 1 second. Yes, and then go to device and then right click and new device, example PLC 1, and use the master part 0 that we already created from here, and click OK, and then go to the IP address. Yeah, 192.168.0.200, right? Link to the Ethernet module, and then click OK, and then go to the points again, right click new point, and then this is the point ID, example sound Q1, and this is the device name PLC1 that we already created from here, and I will use the boolean true, false, on, off, right? And this is the description, example sound system of output Q1, and we will use the person Q1, right, from here. Yes, link from here. So click OK, and then we can duplicate. Yes, for Q2, and change this one to person Q2, and general we can change to Q2 also. Okay, and we can update the project and then start the project. Yes, so wait a moment for starting the project. It takes time around 1.5 minutes. Yeah, for starting the project. So wait a moment. Okay, right now we already started the project. Yes, so in the next step we need to configure the sound system, right? So let's go to start, and then go to all program, and then go to Proficy HMI SCADA. Yes, and then go to alarm sound manager. Okay, so this one, click, and then go to here. Yes, click one more time, and this is existing, I will delete. Yeah, and for the first we go to the project tab and then add the project. Yes, click add the project, and then click this tab, and then choose the sound, because project that we already created is named sound, right? So we need to use it, and then go to setup. Yeah, setup here, and then we can use this one. Example, we can put the name that we want. Example sound. Yeah, or we can put like this, sound, yeah, and then choose this one and this sound again. Okay, just example, we can put another name that we want. Yes, and then go to the modify current. Yes, so let's see here, we got the alarm class from the alarm here that we already created for Q1. Yes, and then we can uncheck the another alarm that we not use, and then click OK and OK again and OK again. Okay, and then we can go to sound, yes, to option and choose the alarm class, because we use the alarm class to sound the system that we link from Proficy machine edition to here. Yes, and then go to stand up. For stand up, we need to create the INI file first, and then we can choose later. Okay, so we can save our profile, yeah, by click here and then go to our project that name sound, and then we can create the name for sound, example sound, yes, system, yeah, and we can click save. And for startup option, we can browse to find the sound system that we already created. Yes, go to drive C and then go to sound, and then this one. Okay, so that's all. So when start up the project, it will run this one, this file. Yes, okay, so we can minimize, and then let's check our device is up or not. Make sure the device is up. It means that we can connect from our PC to the PLC. Yes, so it up like this, it means that it okay. So let's go to the test only one first. Yeah, so let's go to Proficy machine edition, and then let press F12 to turn on. Yes, let's check. Okay, no sound, right? So we will check again for this one, or we can stop and start the project again. Yes, so let me stop the project and start again. Yeah, it will stop also. And then I will go to point again, and then go to the Q1 and choose the alarm. Yes, here we can use alarm state. Yes, and then for this one we can choose the alarm class that we already generate. Yes, from here alarm class. So the name of alarm class that we already created is Q1, so we can choose Q1, and then alarm on state value 0. Yes, so the Q2 is also, but we not yet create, right? So we need to test the Q1 first. So I will update the project and then start the project again. Yes, so wait a moment for starting the project. Yes, okay, so right now we already started the project, so let's check here. Right now it's 0, right? Okay, 0, sorry, Q1, this one 0, right? So I will turn on. Yes, and then let's check sound again, and then make sure our sound system is turned on. Yes, Yes, turn on. And then we can turn on again for check.
Output %Q1 is turned on.
Yes, let's see. Right now we can sound. Yeah, when the output Q1 is turned on. Let me test again.
Output %Q1 is turned on.
Yes, good. Off and turn on again.
Output %Q1 is turned on.
Okay, I will press F12 and then press F12 again to turn on.
Output %Q1 is turned on.
Okay, so right now we need to create one more for Q2, right? So let's go to Workbench again. And we just press dynamic, yes, to create the Q2. And then go to alarm class and right click and create a new for Q2. Yes. And then I will choose audio. Yes. Go to web file and then choose again to the sound. Yes. And then choose the output Q2, right? Click open and then OK. And we can go to the points. Yeah. Go to Q2 and then go to alarm tab. Yes. And we can use alarm state. Yes. And this one I will use Q2. Yes, this one. And tick this one. And then click OK again. Okay. So right now let's check here. The Q2 is also turned off, right? Okay, 0 is turned off. So I will turn on it to test. So I will press F12.
Output %Q2 is turned on.
Yes, this one.
Output %Q1 is turned on.
Okay, turn off again. And I will sound the percent Q1 first. The F12.
Output %Q1 is turned on. Output %Q2 is turned on.
Good. So right now the alarm sound is working as well. Yes. So this is just example and instruction about how to create the alarm sound for the system that link from Proficy Machine Edition and create the alarm system on Workbench. Yes, Proficy HMI Workbench. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say sorry for I have a mistake on this video. And I would like to request all of you to like, share, and subscribe
Q1 is turned on.
my channel also to get more notification and more new videos that I will create step by step.
Output %Q2 is turned on.
In this time, I would like to say thank you very much again and see you in the videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about PLC and SCADA software about how to create the alarm viewer by using software Proficy Machine Edition and Proficy HMI Workbench. Okay. So here is the example that I already created the alarm for show. Example, temperature number 1 is high, temperature number 2 is high, or pump number 1 is pressure low. Okay. So to create this alarm, we have a step to do. So let's go to our step for go to install and set up the alarm. Okay, so let's go. So first I need to create the alarm by using the Workbench software and Proficy machine edition for create the logic for test. And the second we need to create the actual server. Yes, so the first I will install actual server. Yes, so let install. Yes, wait a moment for installation the actual server, because it should be log the all the data to actual server before we create the alarm. Okay, otherwise it not work if we not install the actual server. Okay, so wait a moment. Now it extracting the file. Yes, it take time. Yeah, around 20 to 30 minutes for install actual server. Yes, but maybe this video is so long, but I would like to show to everyone step by step about how to install the actual server and how to configure the alarm viewer step by step. Okay, so it will take time a little bit. Yes, actually we have alarm viewer and alarm history. So in this video I will show about how to create the alarm viewer first, and in the next video I will show how to create the alarm log. It means that alarm history we can check back. It means that back that. Okay, so go to installation and then go to new actual server. Yes, right now I will use the version 2012. Yes, for actual server. Now it extract the file and prepare to installation. Yes, so maybe take time. Yes, running the rule checking. Yes, okay, so it already extract and checking the role. So click accept and then click next for installation. Yeah, and then click next again, and then we go to next. Yes, for installation. Okay, and then go to the instance. Yes, default instance. Here we can use the default of Microsoft SQL Server. Yes, and then click next. And then go to next. Yeah, next step. Okay, so here we can use the data directory. It means that which drive that we would like to keep. Yes, okay, so we can go to a directory and then go to add the user. Yes, this is my computer name and this user administrator, and then go to data directories. Yes, and here is the data that we would like to keep, so I can browse and go to drive C, because my computer has only one drive, and then create a new folder, example SQL data, yes, okay, and then go this tab again and then click next, and then go to install and config, yes, and click next again. It will automatic install, okay. So it will take time a little bit more, yeah, around 10 to 20 minutes, okay. So please wait a moment for installation. Okay, now it was done for installation. Yes, no error occur. It means that we already completed for install. So close the installation. Then let's go to open the actual server. Yes. Let's go to start and go to our program and then go to Microsoft SQL Server 2012. Yes. And then go to Microsoft SQL Server Management Studio, okay, and then go click it. Wait a moment for start up the Microsoft SQL Server Management Studio, yes, and here is the connection, yes. So we need to first open the Windows, yes, authentication, yes, and then click connect. And then we go to security, go to login, and then to change the password of SA, okay. SA means that server administrator, yes, and then I will change the password. We can put another password that we want, but should be remember, yes, and then I enforce password policy, yes, and then I go to status and make sure we check the enable for login, yes, general, and then go to status, yeah, enable this one, and then go to click OK, and let's go to right click and then go to property, yes, go to security, and then make sure we click here, yes, and then here and click OK. So we need to go to disconnect and then go to service for start the service, yeah. So let's go to control panel, then go to administrative tool, go to services, and go to SQL, yes, here, and stop and start again. It means that restart again, yes, and then go to start our program and then go to Microsoft SQL Server 2012 Management Studio again, and here we can log in SQL Server by username SA, password that we already put, yes. So we can click connect, yes. So right now we can log in, yes, and then we need to create the database, yeah, one database. So right click, new database, yeah, and we can put the name simplicity, yes, simplicity like this. Okay, and click OK. Yes, and then close the Microsoft SQL Server Management Studio. Yes, and right now we need to configure the project first. Okay, so let's go to our project that we already learned in the previous video. Yeah, go to sound. Yeah, and then go to project property. Yes, and then go to setting, database logger, right? So first I need to check the project property for database logger first. Yeah, this one. Okay, okay first, and then go to property again, and then go to setting. We have the database logger, but we should go to the ODBC first for configure the SQL data. So go to ODBC, yes, 32 bits, and then go to the system DNS. So here it has 3 options that we will use. The first one is alarms logging. So let's go to config. Yes, and then let's click here to choose the server that we want to connect. Yeah, so wait a moment for connecting. So here we can provide like the server name that we already connect. Yes, like this. Yes, this one. Yeah, so we can copy this one. Yes, and then go to here and then paste and then click SA. Yeah, administrator SA, sorry, log ID SA, and then password that we already put, and then go to database that we would like to connect. So simplicity database that I already created. Yeah, here, and then click next, and then go to here and set the English. Yeah, click finish, test the source. Yeah, it shows like this. It means that we can connect it the database. Yeah, click OK, and then go to the points. Yeah, click config, and then paste the server name. Yes, password. Yeah, and then go to the database that we would like to connect. Click next and choose English, test. Yeah, and one more. I can paste password and then database name, English. Yeah, finish, test. Okay, successful. So right now we already config the server. Yeah, and then let's go to database logger, go to setting, and here is the default alarm connection. So click on it and then put the password that we already put. Yeah, and then click here for point connection. Yeah, put the password. Click like this, we can, it means that we can connect. Yes, if it occur the error, it means that we cannot connect. So we need to check the ODBC again. Okay, so okay, and then click yeah, update our project, and then we can start the project. Okay, start the project. So I will use the points that we already learned about in the previous video about the alarm sound. So here we can go to the points, sound 1 and sound 2 that we already learned in the previous video, and we can right click, but before right click we can dynamic first. Go to the enable log to DB, it means that enable log to database, okay. So right now it already logged, and then we can check here, go to database logger and go to database logger again, and go to data log. We can see the 2 points that we already enable logger. Okay, so let me open the Proficy machine edition for checking the points that we already learned in the previous video. Yes, so let's go to project name, sound system. Yes, and let me online for check the status. Yes, and go to the program block. Yes, okay, here person queue 1 and 2 is turned off right now. So I would like to create the alarm. Yes, so let's go to point and then check the alarm message. Go to alarm. Right now it's alarm state. So if we would like to provide some alarm message that occur, we can change here. Example, person queue. Example, person queue 1 is alarm. Yes, invalid message, so we cannot use the person. So example, output 1 is alarm. Click OK, and alarm should be when the value is 1. Yes,
Output %Q1 is turned on.
it should be have sound because we already config in the previous video. Yes, so this one output 2 is turned on. Yes,
Output %Q2 is turned on.
okay. So like this we can go to the screen and create a new screen for alarm viewer. Yes, okay, I will adjust the geometry. Example, for width 1000. Yes, for width. Okay, one more 1020. Sorry, 1200. Yes, and the height should be 600. Yes, okay, like this. And let's go to drawing and then go to alarm viewer. Yes, okay, click the alarm viewer, and then we can adjust the screen like this. Okay, and then we can go to property, simplicity property. Yes, go to property and then go to project and then add the project. Yes, go to sound. Yeah, it is the project sound. Yeah, so go to sound and then click OK and then click OK. Yeah, let's test. So we can test the screen. Yes, when we test the screen, let's see here, we have output 1 is alarm and output 2 is turned on, right? The same as that we put on point here. It is the alarm message. Yes, let me show here. Output 1 is alarm. Yeah, and then let's check here. Output 1 is alarm. So it is the alarm message. So if I turn on this one, yeah.
Output %Q1 is turned on.
Okay.
Output %Q2 is turned on.
And then let's check here. So here we can clear the alarm. It means that we can reset and acknowledge the alarm. Yes. So if I force off, remove force.
Output %Q1 is turned on. Output
Yes.
%Q2 is turned on.
So here we can acknowledge, yes, the alarm, because we already turn off the output. So if I would like to force the signal again, yeah, let me show. Okay.
Output
Let's see here.
%Q1 is turned on.
The alarm 1 is turned on. Okay, for output number 1. Yes. This one.
Output
Let's see here.
%Q2 is turned on.
It records the time and the alarm message that we already config. Yes. So example, I would like to config one more for alarm. Yes. Let's go to here and then go copy. Yes. Example %Q3, right? So %Q3 and this one %M3. Yes. And start the %Q3 and we can download. Yes. Okay. And then let's go to points. Yeah, to take here dynamic, don't forget, and then we can duplicate for Q3, and this is %Q3. Yes, description. Yeah, and then go to alarm. So here should be %Q3 is alarm. Yeah. So we can change this one to output 3 is turned on. Yes, and then click OK. So we can test. Yeah. Yes, alarm the same as. Okay, enable. So we can force the signal and then let's see the result. So let me force on. Yes.
Output %Q2 is turned on.
Okay, let's see here. The output number 3 is turned on. Okay. It record the same as the timestamp that show here. Yes. And I would like to tell this one also. Don't forget tick the alarm. Yeah. Otherwise it will not work. Yes. So it will record automatically to the actual server. Let me check. Yeah. Go to actual management studio. And then we can connect SA and then go to password and go to database, go to table and then go to data log. Yes, and we can select top row. Yeah, and then let's see the result. Yeah, so let's see here it already record and log to the actual server. Yeah, let's see here timestamp. The value change to 1 or 0, it already locked. Okay, and this is the take name. Yes, point ID, it means that take name, timestamp. Yes. Okay, so thank you very much for watching my video about how to create the alarm viewer by logging to the Microsoft SQL Server Management Studio. Yes, and if everyone have any question, please drop comment under my video. I will reply soon. And this is just instruction about how to create the alarm viewer. And in the next video, I will show about how to create alarm logger. Yes, it means that alarm history. Okay, and I would like to request to everyone to like, share, and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to create the alarm history or alarm log. Yes, by using software Proficy Simplicity Workbench and create the program by software Proficy Machine Edition. Okay. In the previous video, we already learned about how to create the alarm viewer and we already tested. Yes. So in this section, we will learn about how to record the alarm. It means that the alarm one should be record all time when we logging. Yes. When the condition is changed, it should be logged. Okay. So let's go to our software to create the alarm logging. So first, I would like to open the Simplicity Workbench, and I will use the existing project that we already learned in the previous video. Yes, and then let's go to the point. Yes, so for config the actual server and ODBC, I already show in the previous video, so no need to show again in this section. Yeah, and then I can start the project. Yes, and we will create the points more for logging. Yes, the existing point just only 3 points that we already test in the previous video, so we will create more, around 2 or 3 more. Yes, okay. So let's go to open the Proficy Machine Edition first. Okay. and then I will use the existing project. Yes, and then I go to program blocks and create more points, yeah, for test. Example, person Q4, so person M4, person Q4, yes, one more, person Q5, so person M5, start person Q5, yes, and one more for person Q6, so person M6, start person Q6, okay, and then I can download, yes. So right now we have totally 6 output, yes, so we can create 6 alarm also, okay. So let's go to our project of simplicity workbench and then click dynamic, and let's check the actual management studio a little bit to confirm that we can connect to the existing our database, yeah. So I can put the password, okay. It's so like this, it means that we can connect to our database name simplicity, yes, and then go to the points, yeah. So basically we can dynamic, yeah, this point, yes. So I can dynamic, duplicate, yes, go to duplicate Q4, yes, and then change this one to Q4 and go to the description Q4 and then go to alarm, yeah. Actually we can use another alarm class that we want, example high, yes. So person Q3 is turned on, so this one should be Q4 is turned on, yes, and alarm is 1, so click OK, and I can duplicate one more for person Q5, yeah, 5 also, and then this one should be 5, alarm should be 5 also, yes, and make sure you check here is alarm is enabled, yes, yes. For the last one, for person Q6, actually it is just example here, and if everyone would like to show another alarm like temperature is low, temperature is high, pressure is low, we can create, okay. I will show, yes. So should be Q6, and this one should be Q6 also, and the alarm Q6, yeah, number 6, output number 6 is turned on. So if we would like to create the like temperature is high or pressure is low, we can also use, okay. I will example for virtual point, yeah, because it is the device point. Let's see here, it is the device point, and if I would like to use the visual point, I can do also, yeah, by right click and then use the new points, yeah. Example temp 1 high, yeah, temp 1 high, yeah, like this, and I will tick the visual point and then check the boolean, yeah. Example, the description should be temperature number 1 is high, yes, and we can copy this one to the alarm, yes. So initial value example 0. So when we start project, it will 0, and then go to alarm tab, and here we can paste the alarm message that we want, the same as the description, and then we can use the alarm class and another alarm class that we want. Example, I use the high, and then it should be 1 alarm, yes. Okay, and example, temperature number 2 is high also, yeah. So we can write like this, and then go to this one is 2, and let's go to alarm, yes. So temperature number 2 is high, and then don't forget tick here. If we would like to log to database, we should click here to log, yes. This one also log to database, yeah. It means that log to Microsoft SQL Server, yes. Okay, and one more for pressure low, right? Example, pressure number 1 or pump number 1 is pressure low. Pump 1 is pressure low. Yeah. So we can change the description here. Is low. Yes. Go to visual point, the same, yeah. And then go to alarm. Here is the alarm message that it will show in the alarm log page, yes. So we can provide example, pump 1 is pressure low, yes. So we can enable the alarm, yes, and then click OK, yes. So right now we already enable the point to database, right? So re-enable again, and then go to database logger for check. Okay, so right now let's see here the point already logged to database, yeah. So we can go to the screen and create the new screen. This is a existing screen, yeah, that we already learned in the previous video for alarm viewer. So right now we can create one more screen for alarm history, right? So let's go to drawing tab and then go to historical alarm viewer, yeah, and we can resize the screen for alarm logger, yeah. And then let's click double click and go to property, yes. And here we can go to the connection. The first one is project name, yeah. So we can click sound. It is the project name here. And then go to the database logger, yes. So click data log, SQL. So here we can filter, yeah. So here select timestamp as time when log, yeah. So here we can filter Okay, that's all for configuration. And then we can save our screen. Example, alarm logger or alarm history. And then we can test the screen. Yeah. When we test the screen, it has the existing alarm. Yeah, here. Because we already test in the previous video, so it locked. Let's see the timestamp and the point ID. Yeah, that it locked. So if we would like to clear all this alarm logger, we can go to the database logger. Let me clear, yes. And then we can start to fork the signal and then check again. Let's go to here and make sure we click the dynamic and then go to database logger and then go to the edit and then go to reconcile the table. Yeah. And we can drop. Yeah, we can drop table. Yes. Okay, it drop like this. Yeah, when it drop like this, we can test the screen again, and then let's see the alarm. No record anymore. Yes, it means that it empty. So to create new, let's click here and then go to select, sorry, go to the create. Yes, create bond. Yeah, and then click close. So it should be record new. Yeah, so if we force the signal, yeah, let me force the signal, it should be happen the alarm again, both alarm viewer and alarm history. Okay, so if I force the signal, yes. Yes. So right now the output is turned on. Yes. Let's check. Let's see here, all outputs is turned on. So if I refresh the screen again, let's check the alarm viewer. It locked or not. Yes. Alarm history. Alarm viewer is locking right now. But let's check the alarm database logger again. It has. So let's go to the screen of alarm history again. So if we drop the table, we should stop the project and update again. Yes. Otherwise it should be not locked. Yes. So let me stop the project and update the project again. Yes. Okay. Update the project again. And let me clear the lock. Okay. So let's start the project again. Okay. So wait a moment for starting the project. Okay. So right now we already started the project, and then I already forced all the output is turned on. So let's check the history alarm again. Okay. So right now it lock again. Yes, start lock again. Alarm viewer also lock. Yes. So this is the instruction how to create the alarm logger or alarm history. Okay, actually we can call this screen. Okay, let me show. I will create the new screen for call this screen. Yes, example geometry. I will adjust a little bit. 600 like this, or 500. Yes, and if I would like to call, I need the button, right? So I will call alarm viewer screen. Alarm viewer screen. Yes, and one more for alarm history screen. Yes, alarm history screen, and I will adjust a little bit more, example 200. One more for 300. Yes, like this, and then I can configure for open screen. Yes, example if I would like to open the screen for alarm viewer, I go to event and then go to the mouse up. Yes, and then go to the new procedure, new, and then go to the open screen or overlay screen. Let me use the open screen, and here is the screen name. Yes, for alarm viewer. Yeah, we can click and then go to the okay, so we can test screen, and we can open the screen for alarm when we click. Yes, okay, alarm viewer, and one more for alarm history. Right now we cannot click, right, because we not yet config the button. Okay, let me align. Okay, so if I would like to open the history alarm screen, let's go to event and then go to mouse up, go to new procedure, new, and then I will open screen. Yes, and then the screen name is history alarm. Yes, click OK, and then we can test. So I can click, yeah, and then can open the screen of alarm history. Okay, in here we can also sort. Yeah, if we have many time or many days, we can filter. Yes, we can sort filter A to Z, Z to A, or we can hidden the filter, open the filter that we want. Okay, so this is just instruction how to create the alarm history call. Yes, that we want to record the alarm of our machines or our process. We can follow this step. Okay, by install the SQL server for database. So thank you very much again for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon, and I would like to request all of you to like, share, and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to assign the IP address to Ethernet module, yes, by using the software Proficy Machine Edition version 9.5 and the MAC address that already stick on the Ethernet module. Okay, so this is the step of the how to set or assign the IP address of the Ethernet module. The first step, we need to write down the MAC address of Ethernet module that stick on the board. Okay. The second step, we need to assign the manual of IP address of our computer by following the rank that we want to set to the Ethernet module. Example, my computer is 192.168.0.253 and the subnet mask is 255.255.255.0, and I would like to set the IP address for this module. It is just example 192.168.0. yeah, the rank is the same, right? 192.168.0, the same as the computer. And we need to put the MAC address of the Ethernet module here, yes, and make sure the CPU is stopped when we would like to set the IP address of Ethernet. Okay, so let's go to our software to see how to assign the IP address to Ethernet module. Yes, let's go. So first, open software Proficy Machine Edition. Right now I use version 9.5. yes, and we can create the new project. Yeah, so right click new project. Example ETM IP. Yes, and we can create the empty project. Okay, and then we can go to right click on the project and add the target, and I will use PLC system L3i. Example IP ETM. Yes, so basically if we would like to config, yeah, example power supply, yes, to be made with our slide. Yeah, here I use DC power supply and CPU 310 and ETM 001. Yes, so we can also config here. So PSD, and I can drag and drop here, and I use CPU 310, so I can replace. Yes, and then I can add Ethernet module for slot number 3. Yes, here. So right click add module and go to the communication module. Yeah, communication, and then click ETM 001. Okay, And here is the IP address that we will put. Example, I would like to set the IP address 192.168.32.199, yeah, like this. And this is a MAC address, sorry, subnet MAC, yeah. So 255.255.255.0 because it is class C, right? And for in this variable mode right now I use for. So if we would like to change to another variable mode, we can use true, because if we use %i1 like this, when we add the IO, it means that we cannot use the IO from %i1. Okay, so basically we can use the variable mode for true for config. Yes, so I can use true, and we can map the variable, yeah, here. So example, node 01 slot 03 ETM, yeah, and the status bit must be provide 80 bits, right? So I can put 80 bits. Okay, so we put like this, we can use the %i1 from if we add the IO module. Okay, because we already put true for variable mode here and already mapped the variable address, yeah. Okay, so to set the temporary IP or assign IP to the Ethernet module, so we can, so right now we can ping, yeah, by go to window R and then write the command cmd, yes, and then we can ping the IP address, yeah. Let's test 192.168.32.199, right? So ping 192.168.32.199, yes. So right now we cannot config between our computer to the PLC, right? And we cannot online also, yeah. If we click online from our PC to the PLC, we cannot. Okay, so we need to create or assign the IP address to the ETM, right, for slot number 3. So go to here and then right click and go to outline command and go to set temporary IP address. Okay, and make sure we have record from the MAC address, yeah, here should be record this one. So for this one I will zoom a little bit, yes. Okay, so 00099.100 E1 37, right? So I will put 00099, yes, and then botnet 100 E1 37. Okay, 100 E1 37. Okay, and here is the IP address that we want. So 192.168.32.199, right? So 192.168.32.199, right? And we go to make the manual of our computer, and please don't forget turn off the window firewall, otherwise it not work also. Let's go to set the temporary IP for our computer first. So let's go here and then put the rank the same as the IP address of Ethernet module, right? So 192.168.32.example.244, yes. And here is the subnet MAC, yes. So 255.255.255.0, okay. And then go to check the window firewall by go to control panel and go to window firewall, and make sure we already turn off the window firewall, okay. So let's click here and then double click here to check the IP address of our computer. So 192.168.32.244, it's the same as the rank of the IP address of ETM, right? So let's click set IP and then let's click OK, and then wait a moment for setting. Okay, so if it occur like this, it means that we can communication, or we already assign the IP address from our computer to the ETM, right? So we can click OK and then we can ping again. So CMD ping 192.168.32.199, right? Okay, let's click enter. So right now it reply like this. It means that we can communication our from our computer to the Ethernet module. Okay, so we can also online, yeah. Okay, right now we can online to the PLC, and I will assign, I will set some parameter of the CPU first before download. Yes, like this. And for this one, I will use this constant window and the always plus, yes. And this one I will choose run and then save the project, and then we can download, yes. Okay, can download after we already assign the IP address to the PLC, yeah. Fault controller error, let me check. No error, right? We can try to download again. Okay, so I will select the switch, yeah, because last time we already select to off, yes, before we set the temporary IP, yeah. So that's all for how to set the temporary IP or assign IP from our computer to Ethernet module of PLC GE. Okay, so thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to configuration the hardware and testing between CPE 330 to VerSaMax remote I/O of PLC GE. Okay. It is just an example. Right now I will use port 1 for connect from CPE 330 to my computer, and one more for port 2 connect to the remote I/O VerSaMax. Yes, and I will use the digital output one card for test and show how to configure between CPU and VerSaMax remote I/O. Okay. So I will use Proficy Machine Edition version 9.5 and connect from port 1 of CPE to my computer via LAN cable, and also connect between port 2 to the remote I/O by using the LAN cable also. Okay, and I will control the two relays and two LEDs for show to everyone also in this step. Okay, so let's go to our software to make the hardware configuration and testing and configure the remote I/O. Okay, so let's go. So first open Proficy Machine Edition. Okay, and then go to create a new project. Example remote I/O. Add remote I/O. Yes, and then go to empty project. And let's go to add the target, and I will use PLC system AS3i. This one the target name, example CPE IO. Yeah, it means that connect from CPE to a remote IO. And then go to the hardware configuration. So for power supply, right now I use DC power supply, so I will replace the module. And then I will use slot number 1 for CPE 330. Yes. For the default IP is 192.168.0.100, right? So I can go to my computer and then set the IP address for manual mode 192.168.0. something, but no 100, because the default from manufacturer is 192.168.0.100 for CPE 330. Okay, so example I will set dot 250 and subnet mask. Yes, Okay, so we need to go here, and then we can go to Ethernet, and then 192.168.0.100, right, for GPE. Let ping to confirm. So 192.168.0.100. Okay. So let me check. Okay, we can ping for confirm. Example CMD ping 192.168.0.100. Okay, so we can ping from our computer to the CPU, right? So we need to assign the IP address for port number 1 and number 2, right? Totally we have 2 ports. The port number 1 should be connected to the computer, and port number 2 should be connected to the remote I/O, right? VerSaMax. So we will assign the address to the port number 1. So here I can use the variable mode. True, yes. And then for LAN 1, IP address is 192.168.0.100, right? And MAC address, subnet MAC 255.255.255.0. For LAN number 2, we can put 192.168.32. Example.1, yes, and MAC address. Here we can put another rank, but not the same as here. .0 cannot, yeah, because these 2 ports should be not the same rank. Okay, so example 255.255.255.0 for subnet MAC of port 2. And then let go here because we use the variable mode true. So example node 0 1 slot 01 CPE 330, right? And then we can provide 80 bits, yeah, for this variable mode. So 80 bits. Okay. And then we can go to the CPE for assign the parameter. Example, in the setting tab, I will use the run for power up mode. And here is the option that we can select. Example for LAN 1, it means that LAN port 1. Right now I assign Ethernet, yes. And for the port 2, we can also assign Profinet that I will show in the next video. So right now I will use the Ethernet first. Yeah, here is very important. If we cannot assign here, we cannot communication. Okay, and then we can go to the memory. Yeah. Okay, just this one first. And for a percent W example, I can use 2000, yeah, for percent W. And this one I can put, yes, example 512, yes. And for digital input and output, it automatically to the maximum, yeah, we cannot increase or decrease, okay. And then we can download the hardware configuration first before we add the I/O module, right? So we can stop the CPU and then we can download. Yes, and we can write to plus. Yes, and we can start the CPU. Okay, so right now the CPU is starting successfully. Yes, and in the next step we will configure the remote I/O, right, for here. So we can control from the CPE to remote I/O via LAN cable. Okay, so we can go to the offline and then go to the target, add target, and then go to the intelligent platform remote I/O, right? And right now I will use the VerSaMax Ethernet. Yes, so click here, example NIU1 or VS1 VerSaMax number 1. Yes, and here we need to assign the IP address of VerSaMax also. Yeah, so here the first step we need to assign the IP address to VerSaMax, yeah, to be the same rank as that we set on port 2, because we will connect to port 2, right? Let's check here. 192.168.32.1, right? So we will assign the address to be matched with this rank. Okay. So example, I will assign 192.168.32.2. Okay. Because .1 is the CPE IP address for port 2, so I will assign .2. Yes, and then here we can configure by double click. So here is the setting of network, right? Okay, I will close this one first, otherwise we are confused. Yeah, so setting, no change anything. For network we will put the same as here. Yeah, so 192.168.32.2. yes, so double click 192.168.32.2. yes, and subnet mask 255.255.255.0, right? And I will use the EGD for communication between CPE and remote I/O, right? So I will use CPE EGD, right? And then go to the producer exchange. So this is the IP address of producer it means that consume IP address. Yeah. So the consume IP address is 192.168.32, right? .1, right? And for the consume, exchange, yeah, it will start from 1 because we just have only one IP address, so only one VerSaMax. And this is a producer ID. It means that who produced to this remote I/O. So I need to create one more for EGD, Ethernet Global Data, by right click on here and then choose the add component and then go to Ethernet Global Data. It means that EGD. And then I will put some number. Example, I put 10. It should be 10.0.0.0. Okay. So this is a producer ID from 10.0.0.0. Okay. The EGD ID. And for group ID, we will use 0 because we not use it. And for memory and power consumption, we not change anything. So in the next step, we need to okay, I will close this first. We need to add the carrier box style, right? So here, and I will use IC200 CHS022 vertical, yes, and I will use the DO, yes, digital output module, yeah, IC200 MDL 750. Okay, so we can add here, right click, add module. So go to the digital output, right, and choose IC200 MDL 750. Okay, 32 points, 24 voltage DC or 12 voltage, 0.5 M, yes, and then click OK. So it will start from %Q1, yeah, for in this module. So in the next step, we need to set the temporary IP for this remote I/O, right? By set the one more for computer rank IP address for this. So right now, if we would like to ping, yes, for CMD. So ping 192.168.32.2, right? We cannot ping. So we need to put the one more for IP address, right? Go here and then go to property and go to IP4 and go to property and choose the add one. So I will add one more for IP address. Example, add like this: 192.168.32.250. Okay, like this, and then click OK and OK again, close. and we if we ping, we cannot ping also, because right now we not yet set the temporary IP of this module. Okay, so let's start to set temporary IP. Before set temporary IP, we should connect the LAN cable from our PC to the PLC also, right? So we need to have the MAC address of this module also, right? So right click and then go to the set temporary IP of this module, and I will record the MAC address of this module. So the MAC address of this module is 000 99 141 A826 A826. Okay, and the IP address that we want is 192.168.32.2, right? And this is the IP address of our computer. So 192.168.32.250, right? So we can set okay. So right now it's so like this. It means that we can communication between our computer to the remote I/O module, right? So we can ping to test. Okay, we can ping, and then we can download the module to the the program to the module, right? By right click and then download to remote I/O, and then click OK. Yes. So right now I already download to the remote I/O. But if we just configure like this, we cannot control from our CPE to the remote I/O, right? So we need to configure more. Yes. Let me activate this target first. To configure more, we can go to the Ethernet global data and then choose the producer exchange, right? So right click and then choose new. This is a produce exchange 1, right? So we can rename to be VS1 VerSaMax number 1, and then producer. Yeah. And this is a parameter that we need to set and configure. Example, this one is the exchange ID number 1, and adapter name is 1 because we use slot number 1 for CPE, right? And then go to the unicast, yeah. And here is the destination. Destination, it means that the destination that we want to control, right? So 192.168.32.2, right? The IP address of the VerSaMax module. So for run store mode, we can choose true. Okay. And for exchange, yes, we can VS1 consume, yeah. And here is the producer ID. It means that who produce, right? So this one we can choose 192.168.32 dot who produce, right? So VerSaMax will produce to the CPU, right? So .2, and for exchange ID is 1, adapter name is 1 also, and for run store mode we will choose true, yes. And we need to configure this one for remote I/O, right? Double click for a producer, and we need to add the 2 words or 2 integer for status, and 1 integer or 1 word for status, and 2 word or 2 integer for command. Okay, so we need to create the variables, new variable, and I will use integer. So example VSM1 VS1 was 1 for use status, yes, and I will use CPEIO because it is the project name, and I will use 1 integer for array, and I need to more for command, yeah. So example VS1 produce command cmd, and I need 2 integers, yeah, so array 2, and then I can double click here, and then I put the status for 1 integer and the command for 2 integer, and then I will add this IO, yes, so add, and then I will use the %q and start from %q1 32 bits, yes. So we can add the 32 bit for digital output, and then go to the VerSaMax for consume. We can add one more for status, example VS1 consume status, and I need 1 integer also for status, and one more for VS1 consume cmd, it means that consume command, and I need 2 integer, yeah, for this one, and I can double click to add this status, right? So consume status 1 integer, and add one more for consume command, yeah, 2 integer, okay. And then here I can save the project. So we can download, yes, by click connect, and then click download to CPU, yes, okay. So right now we can for the signal for test, yeah, for test the output. Okay, let me go to the queue, yeah, %q, it means that output, and I will show the status right now, yes. So it shows start like this. It means that the status is okay. It means that we can connect from the CPE to the remote I/O. If I take the LAN cable, take out the LAN cable, the signal will lost. If I reconnect again, the signal is okay. And the output point number 1 until number 32 is turned off right now. Yes. Okay, let's test the signal. So I will force the signal to person Q number 1. And the PLC will turn on. Let me show. Okay. So person Q number 1 is turned on and number 2 is turned on also. Okay. Let's see the condition right now. Here is turned on and here is turned on. And I connect from this signal to the control relay and from relay to the LED. Okay. So it's working properly. Yes. So I will remove force. Yes. Okay. And another way we can write a program for test also. Yes. That I will show in the next video. Okay. So thank you very much for watching my video. And if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to connect or configuration the CPE 330 connect to VerSaMax I/O that will test with the digital output module and digital input module. Okay. In the previous video, we already learned about how to configuration the CPU or CPE 330 connect to the VerSaMax I/O. Yes, and connect to the digital output module. And we already tested in the previous video. Okay. So in this video, I will use the software Proficy Machine Edition version 9.5, the same as the previous video, and connect from LAN cable to the port 1 of CPE 330. And for VerSaMax I/O, I will use port 2 to connect to the digital input and output. Okay. And here is the digital output module that we already learned in the previous video. So today we will add one more digital input card, and this is a serial number, MDL, yes, this one MDL also. Okay, IC 200 MDL 750 is the digital output module, and IC 200 MDL 650 is the digital input module. Okay, and there are 32 bits for output, and also 32 bits for input module. Okay, so let's go to our software to configure one more for digital input module. Okay, let's go. So first I would like to explain a little bit for drawing, yeah, for digital input module that we will test after we configuration. Okay, so let me explain a little bit for how to wiring the digital input module card. Okay, so basically we should know how to wiring, otherwise we cannot test the module if we cannot understand about how to wiring. Okay, so this is a card, yes, module, yes, IC200 MDL650, yeah, and there are 32 bits, yeah, from bit number 1 to bit number 32, yes, and the input is 24 voltage DC, yes. Okay, and let's go to the how to wiring, yes, and here is the file wiring, yes. Let's see A1 until A18 and B1 until B18, yes, for connection. And here is the connection for carrier with two rows terminals, yeah, for IC200 CHS002, yeah. And right now I will use this one, yes, with 3 rows, yeah, wiring connection with 3 rows, and for my module is IC200 CHS00200, sorry, 22. Okay, this one. And for number 17 and 18 for section A, let's see section A, we can connect minus or plus that we want. For me, I connect minus for 17 and 18, and for section B also. And for this one, we can test for bit number 1. If we connect this one minus, we must connect to the bit number 1 is plus. Okay, so we can test after we do the configuration. Okay, so this is just wiring diagram, yes. So let's go to our software Proficy Machine Edition for make the configuration. Okay, so let's open. Yes, right now I will use version 9.5 for Proficy Machine Edition, and I will use the existing project that we already learned in the previous video. Yes. Okay. So in the previous video, we already config one module for digital output module. Yes. And for today, we will add one more. Yes. To add the module, the first need to add the carrier box style first. Okay. So right click and then add carrier base. Yes. And right now I will use IC200 CHS022. It is the same hardware that I use. Yeah. So double click. And the second step, we must add the digital input module, right? Follow the drawing. IC200 MDL 650. Yes, this module. Okay. So right click on the slot 2 and then add module, and go to the tab discrete input, and let's go to this one. Yeah, IC200 MDL 650. Yes, input 20 volt DC, positive, negative, logic group 32 points. It means that 32 bits. Okay, so let click OK. And then it will start from %AI1, yeah, for the module. And then we can go to download. Yes, first we need to set the active target here. Right click and then set the active target. Yes, otherwise we use this one. Yeah, if we use this one, we can set the active target. Yeah, so if we download online download, we can online to this one, this target. But in this case, we will use this target. Yeah, so set the active target here, and then click validate to check if error or not. Yes. Okay, it's so like this. It means that it not error. And please wait, I will disconnect the LAN cable from the CPE to connect this one. Yes, let me show how to connect. Okay, right now I use this LAN cable for connect to the computer. So I need to take out this cable first. Yeah. Okay, and then go to here and then unplug from CPE and then connect remote I/O to the computer. Yes. And we will test with the button start and stop and show the LED also. Okay, after we download. So right now I already connected the LAN cable from computer to the remote I/O VS1. Yeah, and the IP address is 192.168.32.2. So the first step we can ping for test. So 192.168.32.2. Okay, it's already, it means that we can connect from our computer to the remote I/O. Okay, so we can right click and then download for the new card digital input module that we already configure. Okay, so download and then click OK. Okay, so right now we download complete, error 0 and warning 0. Yes, so let's go to the top for set the active target here, and then we must add more for consume, right? Because we use a digital input module. Okay, so double click on consume. Yes, and then add the button. Yeah, click add the button, and it will start from %I1, right? So go to discrete input and %I1, right? And this one is 32 bits. Yes, because we use 32 bits. So that's all. We can save and then check the validate. Yes, and let's check the IP address here. So 192.168.0.100, and let's check here my computer. Okay, I use two IP address for this one. Let me show. The first one is 192.168.0.250 and the second IP for VerSaMax rank 192.168.32.250. Okay, so let me ping for test. So CMD and then ping 192.168.0.100. Okay, cannot ping, right? So I will unplug the LAN cat ball from VerSaMax remote I/O to connect with CPU part. Okay. Okay, so I will unplug from this one to connect this one. Yes, part 1 of CPE, and then I will connect this. Yes. So let me ping again. Okay. So right now we can ping from our computer to the CPE, right? So we can online for download. Okay. Let me download. Okay, done. So to test the signal of digital input module, let's go to here and then go to reference table. Yes. There are two ways for test this one. This one is digital input also, but it's so much, yes, so many digital input, so we difficult to see. So I will use this way. Yeah, right click and then new, and then this one we can use test. Yeah, test table, and then double click, and we can type for person I want. Yes. Okay, so it will start from person I1, and I will push the button for test with person I1, right? Person I1 and person I2. Right now I already connected the push button to this point. Yes. So let me test. So if I push button, yeah, this one, let's see, the LED is green. Yeah, it means that it's on. And let's see, the computer is on also for signal. Yes. And one more for this button. Yeah. Button I2 is turned on also. Yes. Okay. So we can write the sample program for test. Example, okay, I will outline first. And then let's go to the program blocks. Go to main, yes. So we can write the logic for test. Example, NO, person I1. Example, start, or I will use NC for stuff. So NC con. Example, M1 underscore stuff, and NO con M1 underscore start, and I will use quiet, and M1 underscore CMD, yes, and I will hold the signal also. Yeah, quiet, sorry, NO. yes, for hold the signal. So I will copy this one, yeah, Control C and then paste here, and I will assign the address, yeah, this one for person I1, yes, for stop, and this one for person I2 for start, and this one for person Q1, yes. Sorry, person I2. Okay, so I will save the project and then download and test with the LED and push button, yes. Okay, download. Okay, finish. So let's test. I will show the status. So if I push button start, let's see here, LED is turned on, and push the button stop, yeah, LED is turned off, okay, turn on, turn off, and the status on the PLC is work also, yes. So if we would like to turn on one more for person Q, yes, we can parallel, yes. So I can copy this one and paste, and this one for M2 CMD example, and I will assign the reference address for person Q2, yes, and then make download again. Okay, no need to stop the CPU for download the logic, yes. Okay, okay, let me test again. It will show with 2 LED, yes. So if I push the button start, let's see, LED is turned on because person Q1 and person Q2 is turned on also, and it hold the signal, yes. If I push stop, it will stop. Okay, start again, stop, okay, start again. So this is an instruction how to configure the digital input module and output module for CPE 330, okay, for remote I/O. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to configure the I/O module from VerSaMax I/O to CPE 330, yes. In the previous video, we already learned about part 40. Then we already connected the CPE 330 to remote I/O, and we already tested with the digital output and digital input module. Okay. For today, I will add one more for analog input module, IC 200 ALG 264. Yeah, it is 15 bit and 15 channel. Yes, and I will use the software Proficy Machine Edition version 9.5 to download and configuration the program to the CPE 330. Okay, and I will use the port 1 for connect from CPE to the computer, and use port 2 to connect from CPE to the remote I/O. Okay, so let's go to our software to make the configuration and then download to the PLC. Okay, so before go to our software, I would like to explain a little bit for how to wiring this module analog input. Okay, so let's open. So here is the analog input module, 15 bits current and 15 channels. Okay, it means that we can use the 15 channels for current 0 to 20 milliamp or 4 to 20 milliamp. Okay, and this is the module overview. Yes, and let's go to see the wiring. Yes, how to wiring. So I will use the same the carry base style. It is the 3 rows, right? And we use only part A, section A. Yes, and for section B we spare. Yeah. So for terminal number 17, we can connect minus milliamp minus. Yeah, let's see, here is the minus. Yes, so we can jumping the cable to the terminal 17. Yes, for minus. And if we would like to connect with the standard source current, it means that the current input, we can use terminal number 1 for plus. It is the I1. It means that input analog input number 1 or channel number 1 until channel 15. Okay, so we can connect minus to 17 terminal, and we can connect plus milliamp to the terminal number 1. Okay, and this is a current source. Yes, we can read for easy to understand, and it is the range. Yes, it is the range for 4 to 20 milliamp input current. Yes, and this is the range 4 to 20 milliamp. Yes, this is the data test. Yeah, 0 to 20 milliamp also we can select when we config. But normally we use 4 to milliamp to 20 milliamp for connect from instrument devices or electrical devices. And here is the formula. Yeah. Okay, so that's all for this manual operation. The first one, we must know about how to wiring, and the second one, we must know about how to configure the range. Yeah, there are 0 to 20 milliamp and 4 to 20 milliamp. Okay, so let's go to our software to make the configuration. Yeah, so let's open Proficy Machine Edition. And then go to the existing project that we already learned in the previous video. Yes, let's open. Okay, and let's go to the VS1 for add one more for analog input modules. Yeah, to add the analog input module, the first step is add carry based style. Yes, so add it, and right now I will use IC200 CHS022. Yes, vertical, and then right click here, slot 3. Yes, and then add module, and go to the analog input tab, and then choose IC200 ALG 264, the same as my slide that I already shown. Yeah, here it is this module, and then double click, yeah, for add the module. So let's check here. There are two options for use. The first one is 4 to 20 milliamp. The second one is 0 to 20 milliamp. Yes. So right now I will use this option because I have standard source 4 to 20 milliamp. Yes. So let's use this one. Okay. And this one, no need to set anything. And then let's click here, and it will start from %AI1. Yes, if we test on the IO table, we can write start from %AI1. Okay, so we need to save the project and then download to the VerSaMax IO, right? So right click and then set the active target. Yeah, let me disconnect the LAN cable from the CPE to connect to the remote I/O. Okay. Okay, so right now I already connected the LAN cable from my computer to the remote I/O that has IP 192.168.32.2. Yes. So we can ping for test. So ping 192.168, sorry, 168.32.2, right? Okay, we can ping. It means that we can connect from our PC to the remote I/O module. Okay, so right click and then validate for check. It must be no error. Yes, no error occur. So we can right click and then download to remote I/O. Okay, and then click OK. Okay, done. Download successfully, complete with no error. And then let's go to here, target, our target, and then set as active target. Yes. And then I will take out the LAN cable from the remote I/O to connect to the CPE. Okay. So we need to configuration on the consume, right? Because we use analog input. Yes, analog input or digital input we must add in consume, and for analog output and digital output we must add produce, right? Produce, it means that produce something to another device, and consume, it means that consume from other devices. Okay, so right click on PS1 consume and then add one more for analog input, right? So click on add and then go to the tab for AI, right? Analog input, and then it will start from 1, and it is 50 word, right? Okay, so 50 word, it is a 50 channel, yes. So that's all, and then we validate to check our program error or not. Okay, no error occur, so we can online and then download. Okay, download. Okay, right now we already download, and I have the recommend when we configure the consume and produce, we must tick this one to true if we don't want to stop the CPU while we download. Otherwise, if we select false, we need to stop the CPU before we can download. Okay, so this is a technique. So to test the analog input signal, let's go to the table. Yes, our table. So double click on test table that we already created in the previous video. So I can type a version AI1. Yes, and let me adjust the milliamp. Okay, let me show. So right now I already connected the cable. It is the minus from this one, and it is plus from multimeter. Yes, and select to current DC. Yes, okay, current DC. So right now it show 4 milliamp from my source. Yeah. So if I adjust to 8 milliamp, yes, the raw data is show also. Let's see here. Okay, 12 milliamp, yes, 16 milliamp, and 20 milliamp. Yeah, 20 milliamp is it is the maximum. Yes. So let me show on the manual operation. So our manual operation is around 32,000, right, for 20 milliamp. Yes, and this one around nearly 32,000. Okay, so it is accuracy error a little bit. Yeah, so it is 20 milliamp. So if we would like to test the point or channel number 2, we can disconnect from channel number 1 and then just connect to channel number 2. It means that terminal number 2. Yes. Okay. I will show. Okay, let's see here. I already connected to terminal number 2 from the source device. So if I adjust 8 milliamp, yeah. Let's see. Here is have raw data. Yes. 12 milliamp, 16 milliamp, 20 milliamp. Yes. And it show the raw data is correctly. Okay, it's so nearly 32,000 for raw data. Yes. So if we would like to connect from the instrument, we can use this step for connect and making the rank for show the signal. Okay, and I will explain in the next video about how to connect with the rank or scale that we already learned in the previous video. Yes. So it is the instruction how to add the analog input module to CPE 330. Yes, and test with the source devices that connect to the multimeter for compare. Yes. So if everyone have any questions, please kindly drop comment under my video. I will reply soon. And I'm also sorry if I have mistake in this video, and I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to test the analog input of PLC GE. Yes, this module is IC200 ALG264. It is the 15 bits and 15 channels. Okay, and here is the testing. I already connected the loop current calibrator from the connection to zero with the multimeter current. Yes, milliamp, and connect to the terminal. Terminal number 1 is plus, and terminal 17 is minus. It is milliamp, 4 to 20 milliamp. Okay, and in the previous video we already learned about how to configure for add this module to the CPE 330 by using Proficy Machine Edition version 9.5. Yes, that connected with the VerSaMax IO, remote IO. Yes, via LAN cable. And I already connected the LAN cable from my PC to the LAN number 1 of CPE 330. Okay, so this is just wiring, and I will explain more in the detail of this drawing. Okay, so the concept is right now we need to create the scaling to show example. When I set 4 milliamp, it will show the actual temperature or pressure or some scaling to show the actual value. Okay, so it is just example for one channel. For other channel we can connect minus the same and plus to channel number 1, number 2 until 15 channel. Okay, so let's go to our software Proficy Machine Edition version 9.5 to create the scaling for show the value. Yes, so let's go. Okay, first let's go to open Proficy Machine Edition. Okay, and then go to the existing project that already learned in the previous video. So let's go to add remote I/O. It is the existing project. So for the hardware configuration and VerSaMax I/O, I already explained in the previous video. So today no need to explain more, because in the previous video I already explained and detailed step by step about how to configure hardware configuration or create the EGD, yes, for consume and produce, and already connect to the CPU also. Okay, so here is the module that we already configure in the previous video. So it will start from AI, yes, AI1, and we can see here Ethernet global data consume, right, because it is input. So it will start from AI1, %AI1, and 15 volt. It means that 15 channels, yes. And I need to download the existing project to the CPU again, yes. And then let's go to check the IP address of the computer. First, let's check the IP address of the CVE, yes, 192.168.0.100. So we need to put the manual IP address of the computer to be the same rank, yes. So 192.168.0.253, yes. Actually, if the automatically configure, it will show like this, yes. It is the automatically IP. So we need to put the manual IP address, right? So let's go to put the manual IP address to be the same rank of the CPE, yes, that we already connected the LAN cable to the CPE. Okay, so we need to put 192.168.0.253 or something, but not .100. Okay, otherwise it will complete the IP, yes. So let's click OK. And right now I already connected the LAN cable, yes, from here to the CPE. So we can ping 192.168.0.100, right? Cannot connect, right? Let me check again. 192.168.0.253, right? Okay, that's correct. But why cannot ping? If we cannot ping, we can check the window firewall, yes. Okay, right now it closed. Okay, correct. And then we can write the A or P space A to check the all IP address, the static IP address. So here 192.168.0.100. So we can A or P, type A or P space D, and then 192.168.0.100. Okay. Sorry, ARP D 192.168.0.100. Okay, and then we can start ping again. 192.168.0.100. Okay, so right now we can ping, yes. Then we can go online. I go here online, and then we can download the project to the PLC again. Yes, equal, yes. So for hardware configuration, we already download. If we not yet download the hardware configuration, we can stop and then go to download, and then go to logic, yes, and then download all. Okay, so I will put like this, and then go to view, and then companion. Then I will put like this. Okay, so good. And then we can go to the I/O table to test the signal of the analog input before go to create the scaling for test, right? So test table, and here is the analog input signal, right? I will run the CPU, yes. So let's see, here is the signal from channel number 1, yes, that I already connected the loop calibrator here to the channel number 1, yes. So I will show if I adjust the value of the milliamp, it will vary also, right? Okay, let me show. Okay, let's see, I already connected the minus from the loop calibrator here to the terminal 17, yes, and plus the read with the multimeter, and then connect to the terminal number 1 of carry box type part A, yes. So right now the milliamp show around 16, and raw data around 24 something, right? So if I adjust the loop calibrator to 4 milliamp, yes, okay, 4 milliamp, it show around 0, right? Okay, so low scale is 0, and then if I adjust to 20 milliamp, let me adjust 20 milliamp, okay, 21, 20 milliamp, right? Okay, around 20 milliamp, it will show around 32,000, yes. Okay, so high scale is 32,000, yes. So we can configure the scaling. Okay, so right now we can configure the scale, yes. So the raw data 4 milliamp is 0 and 20 milliamp is around 32,000, right? Let me explain the drawing. Here is the drawing. Analog input 15 bits and 15 channel. Yeah, this is a card module, and let's go to see the scale, right? Here is the connection. Yes, we have a current source. Yes, like this, and here is the how to wiring. So we need to connect the plus to I1, right? And I2, I3 until I15 is positive, and for minus or negative milliamp, we can connect from the terminal 17, and we can jumping to all the terminal, right? So we will got the raw data, yes, that I already saw in the Proficy machine edition. And here is the current testing scaling, yes. So when 4 milliamp, let's see here, and here is the maximum, yes, 4 until 24 milliamp, and here is the raw data that got from milliamp testing, yes. This is 0 to 20 milliamp, and this is 4 to 20 milliamp, okay. So this is a formula, yes. So we can create the scale, okay. This is just manual operation and drawing of this module, okay. So we will create the scaling, yes. So first I need to create the function block, yes, because in the previous video we already learned about how to create the ladder, right? So in this section I will create the function block. So before create, I will show the formula a little bit. Yeah, this is a formula. Actually the value that we got here, yes, it is the integer, right? Yes, here it is integer, so we need to convert to real, right? Here, so we need convert from integer to real, and then we will got the high scale parameter minus low scale parameter, and then divide by maximum around 32,000 for raw data, and then plus with the low scale, okay. So we need to convert from input from integer to real, okay. So let's go to create, followed by this formula, yes. And here is the Excel file that we can simulation. Example, the scale around 0 to 100% or 100 degrees Celsius. If I put 0, raw data 0, it means that 4 milliamp, yes. So the actual of temperature is 0, okay. So if I put the middle, right, 32,000 minus, divide by 2, it will show 50 degrees Celsius. And if I put 32,000, it show around 100% or 100 degrees Celsius, okay. So we can create the formula by follow this step. So let's go, and I will outline first, disconnect, and then go to the main program, yes. Okay, I will create the function block. Example, scale SCLAI, yes, as scale of analog input, and then go to main, and then here we can call, right? We can call the main, so we can call this block to main program. Okay, and we can double click to write inside the function block, right? So here is the function block that we can create the scale, yes. So right now I don't want to create the library, so I will create one for use to show to everyone first. So we need to follow our formula, right? So convert from integer to double integer, convert from integer to real, right? This one I will copy. So Control C, and then I will write command, example text, and we can paste. Yes, this is the formula. Okay. Okay, I will zoom a little bit. So we need to convert from input to real, right? This is 0.0, right? So integer to real, yes, and this is the input, example input 1, or we can write sensor 1 input, yes, and we need to create the high scale, right? Example, so we can use subtract. So sub between this one, sorry, between high scale, yeah. So example, sensor 1 underscore high scale, yes. Or we can write the high scale here. Example, 100.0 degrees Celsius, right? So the low scale is 0.0. We can write like this. And we need to divide this one by 32,000.0, right? So divide 32,000.0 because it is the real. And then we need to multiply by input, right? So we can use mul. Actually this one we can adjust like this. Yes, easy to understand. So I will multiply this one and this one, and we can adjust like this. And I will add with the low scale, right? So I will choose add with the low scale. So low scale we can choose 0.0, right? 0.0, and we will got sensor 1 output. Okay, so sensor 1 actual or output, I will use actual. Okay, like this. So for this one we need to put the address right here. So it will start from version AI1 that I already connected the milliamp to this terminal. So I can use property and then put the version AI1. We already assigned, right? Okay, let me check. Maybe we use another logic. Okay, so we can copy this one to use. I will take out this one first, or we can use the channel number 2. Let me use the channel number 2. So channel number 2 is version AI 2. Yes, and I will swap the terminal from terminal number 1 to terminal number 2 of the PLC module card. Okay, so let me download the logic. We will got error 1, right? Let me check. Invalid input. Oh, this one, right? It is the real. This is a integer and this is a real. It is the real. Oh, this one, right? Need to change to real. This one also. Okay, change the data type to real and validate again. Error 2, right? So real, it is the real. Should be real. We will change the data type to real, right? All data type is real. Let me offline first and then revise the data type again. It should be real, yes. We can use the variable. Let me delete first. It is the real, right? So let me drag and drop again. Should be real. Okay, I will use the variable. Example, temp1. It is the real. Yes. Temp2, it is the real also. This one, right? So this one should be temp3. The data type is real. Yes. And this one should be temp4. Yes. Temp4 also. Okay. So let's check again. Real. This is a real. Okay. Input integer. Yes, correct. So validate again. So we will got error 0 and then we can download. Okay, download. I will adjust a little bit to easy to understand. Yes. Yes, like this. Then we can download again. Okay, so right now the raw data is show 0 because I already I'm not yet connect the cable to channel number 2. Yes, so let me connect to channel number 2. Okay, so right now I already connect to channel number 2, and then we can adjust the milliamp. Right now the actual temperature is show 0. Yes, because input is 0 also. Okay, so let me show the adjusting the milliamp. Right now the milliamp is 4 milliamp, right? So if I adjust to 8 milliamp, yes, let's see here around 24 degrees Celsius. Just one more, yes, 12 milliamp, around 49. Yes, it is the middle. The raw data is around 16,000. If I adjust more, 16 milliamp, around 75 degrees Celsius. Adjust to 20 milliamp, around 199 degrees Celsius. Yes. So the scale that we created is correct. Yes. Or we can adjust a little bit. Adjust. Yeah. The value will decrease or increase. Follow our adjusting. Yes. Okay. So it's very easy. If we have the loop for a calibrator, we can use to adjust a little bit adjust, or we can use like this to adjust step, yeah, from 4 to 20 milliamp, yes, like this. So the next step, we need to show this value to the HMI, right? So let's go to config the project for HMI. Yes. Let's go. So first open the Workbench. And create the new project. And we need to put the username and password. Example, I will put username administrator, and password we can put another password that we want. Okay, I will put password. Yeah, like this, and then click next. And we need to create the new project, right? So I will save to desktop, yes, or save to drive C. And I will put the driver protocol, yes. Right now I will use the driver, yes, S90 triplet, yes, and the project example CPE 330, yes, and then go to OK, and then go to the port, right? Go to equipment and go to create the port. So we will choose the port that we already config on the option, and we will start from port 0. And here I can use 1 second. It is default, yes, no need to change. And we need to create the device, right? So example PLC 1 or CPE 1. So this is the port that we already created. And we can choose the PLC system, yes. And here is the IP address that we connect to the CPE, yes. So 192.168.0.100. So 192.168.0.100. Yes, click OK. And then we can test. We can start the project, and then we can test the device. So waiting a moment for this starting. Okay, so right now the project is started, and we can test the device. Yes, it show device up like this. It means that we can communication between the HMI with the CPE. Okay, so we need to create the points. Yes, before create the point, I need to put the address here. Example, I will use %S for show the actual temperature, right? So right click and then click property, and then go to reference address. I can put the %R. Yeah, it will start from %R1. Yes. And then I can download again, connect and then download again. Actually, this one we can also show it on the HMI, yeah, by put the %R also to check. Example, %AI, right? Okay, %AI. So we will create the points. So I click dynamic and then click new point. Example, sensor 1. Choose the analog and then choose device. And here is the device name that we already created. So I will choose real because I need to show the actual temperature here. Yes. So the data type is real. And I will put %R1 because here is the %R1. Yes, let's see here. And then click OK. And for description, we can also mention example temperature sensor 1. Okay. And I need to create this one also to show on HMI, right? So I need to use the new and then create the point. Example, position, no, AI2. Yes, example AI2. And it is the analog and choose the device also. So this one should be integer, right? And then I will change this one to, insert this one to %AI1. AI2. Because we use the AI2, right? Here. Okay. And then here we can mention the command. Example, analog node 1 channel 2. Yes. And then we can go to the screen and then create a new screen. And then we can write the text string. Example, show the actual temperature I will change the font to be bigger than this. Example 16. Font size, yes. And we need to create the rectangle. Yes, one rectangle like this. Change the color to be white. And I change this one to black. And then I will create the text string and write like this. Put like this and then arrange to be center and middle. Yes. And the unit I will put degree Celsius, right? So I will put like this. See? And I will adjust this one to be smaller than this. And can like this and then change color to be white for unit. And we can group. Right click group and we can like this. Okay. So here I can copy and can rename the text to be sensor 1. Okay. And then I can copy one more for show the person AI 2, right? Okay, person AI 2. And then this is no unit, right? So like this. So I will change the color to be yellow. And we can zoom, yes, like this. Okay, so this is a person AI 2 value, and this is a actual temperature, right? So I need to put the points, go here and then go to the display value expression, and then choose the brow point ID. Yes, and I check the brow and screw to find the AI2. Yeah, here, and it is the integer, right? And it is the output. Yeah, no need set point action. And for this one I need to put the actual value, right? So brow, and then go to see the sensor one here, or we can search like this. Example, right sensor and then star, and click brow. We will filter only sensor one, and it is the real, right? And it is the precision. Example 2. It means that the decimal is 2 place. So we can save the screen, and then example screen 1, and we can run the screen to check. Yes, oh, like this, it's okay. I will adjust the text a little bit to be like this, and then adjust like this. Yes, this one should be like this, and then we can test the screen again. We will got, okay. Okay, and then I can online. So right now it show around 7,962, right? And for the actual temperature around 24 degrees Celsius. So let me adjust the milliamp a little bit. Okay, let's see like this. Can adjust like this. Okay, so let's see, compare with the milliamp. Right now milliamp around 8, right? Okay, let me show. Okay, right now the milliamp show around 8 milliamp, and temperature around 24 something, right? So if I adjust to 11, sorry, 12, it will show around 49, yes. 16, around 34 something. 20 milliamp, around 99.87, right? So in nearly 100 degrees Celsius. So if I decrease the milliamp, yes, it will show like this. Okay. So we can test it like this. So if we can write the program inside the Proficy Machine Edition, we can also write the screen to show the actual, yes. Example, we need to show the one more temperature inside the screen. We can add, yes, but actually we can write as a library, yeah, for this block, and we can drag and drop to use, yeah, easy to use, because we no need to create one by one. It take time, yes, so we need to create the library and then drag and drop to use. Okay, but in this video I just show and share about how to use the scaling of analog input 4 to 20 milliamp and 0 to 100 degrees Celsius. It is just example. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video also, because my English is not so good, but I just want to show to everyone. Okay, so in this time I would like to request all of you to like, share and subscribe my video also, to get more notification and more new video that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to add one more analog output module that we can add to the VerSaMax I/O module and then connect to the CPE 330. Okay. In the previous video, we already learned about how to scale the analog input, and then we already testing with the actual, yeah, by using the loop calibrator for test the signal, and we also create the function block for show the actual of the temperature by using the raw data that got from analog input, yes, signal. But in this video I will show how to add one more analog output module, IC200 ALG 331, by using the Proficy Machine Edition version 9.5. Okay, so let's go. So first open Proficy Machine Edition. And then go to existing project that we already learned in the previous video. Okay, and we need to create one more for this one, right? Because right now we just created 3 modules of I/O module, yes. Here is the 3 module, yes. So right now we need to put one more module, IC200 ALG 331. To add the one more module, right click and then add the carry base. Okay, and then we will create the IC 200 CAS022, right? And then right click here and then add module, and we need to add the analog output module, right? So let's go to tab analog module and then choose the module that match with the serial number of the card that we want to add. Okay, so this one analog output 16-bit volt or current. Yes, it is 4 channels. Yes, so click it here. We will got the new module that start from address %AQ1. Okay, and the length is 4 because it is the 4 channel. Okay, so we need to download the new module to the VerSaMax, right? So for VerSaMax, here is IP 192.168.32.2. Then I will change the mode of this one to set as active target, and then I will change this one, change the manual IP computer to match with the IP address of this module, right? So the IP computer should be 192.168.32. Yes, and dot something, yeah, dot 253. So I will keep the same. Okay, and then I will change the connection. Yes, from CPU, sorry, CPE to the LAN cable to download the program, right? So let me show. So here is the connection, connect from our PC. So let it connect, and then take it to connect to the remote I/O module VerSaMax. Yes. Let me unplug and then connect. And then we connect again. Yes. So here is the cable from VerSaMax connect to the computer. Yes. And this is a new module that we just insert. Yes. Totally 4 modules. Yes. So first we need to ping to check the IP address of this VerSaMax, right? So let's go to CMD and then ping 192.168.32.2, right? Because it is the IP address of VerSaMax. So it shows like this. It means that we can communication between our PC to the VerSaMax remote I/O. Okay. So we can right click here and then download to remote I/O. And then click OK to confirm. Yes. So right now we already download the program to the new module. Yes. And then we need to add the EGD, right? Ethernet Global Data. So let's go to EGD and then go to producer, right? Because it is the output. Yes, analog output. So it should be a producer, and go to producer and then choose this one. and we need to add one more module, right? So click add and then choose the analog output. Yes, scroll to find the analog output. So it's so many I/O that we can add. So I will choose AQ. It means that analog output, and then it will start from 1. So I change this one to 1 and then click OK. So I will change this one to forward because it is 4 channel. Okay. And I need to go to the target and then set as the active target for this one, because for this one we already download the new configuration to the module. So I will go here and then I will change the IP address computer to be .0. Yeah, 192.168.0.253. And then I will unplug cable from the VerSaMax remote I/O to plug on the CPE. Okay, let me show. Okay, I will unplug this one and then plug to the CPE. Yes, and then plug the cable from here. Yeah, from this one to the VerSaMax remote I/O. Yes. Okay. And it will blink the lamp, right? Let's see. So we need to download the new configuration to the CPE also, right? So online, and then I will stop the CPU, right? Because we add the configuration. So we need to stop the CPU and then click download, and we need to download all. Okay, and then we can start the CPU again. And then let's go to see the VerSaMax remote I/O module. Okay, let's see the VerSaMax remote I/O module. So start. It means that it okay, connect from the CPE. If I unplug this cable, let me unplug this cable. Yeah, let's see. The lamp is not show and state is not turned on. Yes. When I plug again, yes, it will blink and start again. Okay. So we can check this data. If it show like this, it means that configuration is okay. Yes, like this. So we need to test the analog output, right? To test the analog output, we can go to the test table. Test table here. And then we can type the percent AQ1. Percent AQ1. Okay. And for percent AQ1, I will explain a little bit about the raw value. Yes. So let's open the drawing. Here I see S7-200 ALG 331. Yeah, it is this module. So let's open. Then I will explain step by step about the concept and drawing how to connection. So this is a module, yes, 16 bit for isolate output, yes, and this is a module number, and this is a top view of the card, and let's see the description we can write, we can read. And here is the principal, yes, terminal wiring, yes. So A1, B1. So we use the B, right? B part. B1 until B18, yes. So B1 is I1 plus, B2 is I1 minus, and this is I mean that current, V mean that volt, yes, and he is the current source, he is the current sink, yes, it's already explained, yeah. So we use the 3 step of terminal, right? This terminal 3 row, yes. So this is a connection. If we would like to use the current, we can use terminal number 1 and number 2, yes, of B part. This is the A part and this is the B part, and here is the ground cable that we can connect to the A part. So right now I use I1, it means that current, yes, and this is I2, I3 and I4. So I use 4 for current, and this is power supply. 18, it means that plus, 17 minus 24 voltage, yeah. So we must follow this connection to connect for test or to use for our plant, yes. So that's all for this configuration or connection. So the next step I would like to explain the low value and high, yes. Here is the low value or engineering low. Let's see here. It means that the raw data for 1000, it means that 4 milliamp, and 20,000, it means that 20 milliamp, yes. So it will start from 4 to 20 milliamp also. Let's see here. 4 milliamp to 20 milliamp, 4 milliamp, 4000, 20 milliamp, it means that 20,000, okay. So we will follow this value to test our channel. So let's open here. So if I put 4,000, it means that 4 milliamp. Yeah, let's me show the multimeter. Okay, right now I already connected the cable from this terminal and this terminal, yes. And here is the milliamp. Right now it show around 4, yeah, 3.94, yeah. It error a little bit. So if I adjust the value, yes, follow the drawing. 4, it means that 4,000, 4 milliamp, right? So if I put 20. Let me put 20,000. Yes. It will show 20 milliamp also, right? So if I put 8,000, for example 8,000, it should be nearly 8 milliamp, right? So it's working properly. If I put 9,000, it will show around 9 milliamp, 8.9 something, so nearly 9 milliamp, right? So if we would like to use other channel, we can test also. Let me test one by one by wiring. Yes, change the wiring. So if I would like to use the channel number 2, I will wiring the terminal to channel number 2. So channel number 2, it should be this one, right? I2, this one, 5 and 6. Okay, I will show. Right now I already swept the terminal from terminal number 2 to terminal number 6. So right now AQ2 here, let's see, AQ2 here is 0, right? Let me show the milliamp. Okay, I already switched the terminal number 2 to terminal number 6 here. Then right now it shows 0 milliamp. For example, I put 4,000. Okay, it shows around 3.94 milliamp, right? If I put 8,000, it shows 8 milliamp. If I put 1,200, it will show 1.12 milliamp, right? If I put 1,000, 12,000, right? It will show around nearly 12 milliamp. Yes. If I put 20,000, it will show 20 milliamp. Okay. So it works properly. So this is just example about how to wiring and how to test the analog output of PLC GE that we can configuration and add the producer ID and we can use. Okay. So actually we can use this one to control the VFD or control the control valve, water valve or something that the signal is 4 to 20 milliamp. So we can use this instruction. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the scaling of analog output with PLC GE, IC200 ALG 331 and connect to the control valve. And here is the analog output module, and I will send the 4 to 20 milliamp to the control valve, and the control valve will feedback 4 to 20 milliamp also to the PLC analog input, and then it will show on the HMI. So we need to create the set point value from the HMI and send the signal to the analog output and then connect to the control valve. Okay, and I will use Proficy Machine Edition and Proficy Workbench in this section to create the logic and the HMI and connect to the CPE 330. Okay, and I already connected the LAN cable from my PC to the port 1 of CPE, and the LAN 2 I will connect the LAN cable to the remote I/O. Okay, so let's go to our software. So first, let's open Proficy Machine Edition 9.5. And I will use the existing project that we already learned in the previous video, this project. And we need to convert the scale from the set point value to the raw data to set point the control valve, right? So I would like to explain a little bit about how to create the scale, yes, for analog output. Actually, this formula we already learned in the previous video, but I just review and then create to use with a control valve. Example, here is the low scale 0% to 100% because we need to open the control valve from 0 to 100%. And here is the output, yes, the raw data. So for analog output, this channel 4000, it means that 4 milliamp, and 20 milliamp is 20,000, yes. So if I set 0.10%, it will show 5,600, and if I increase to 25%, it will 8 milliamp or 8,000. 50%, 12 milliamp, yeah. 75%, 16 milliamp, and 100%, it will 20 milliamp. Okay, so this is the formula, so we need to follow this formula. So let's go. So I will create we can go to our logic that we already learned in the previous video here. Then we will create one more for analog output, right? Scaling. So I will adjust this one a little bit about the high, right? I will set to 25. Yes, to be longer than this. Yes, okay. And then we need to create the formula, follow the Excel file that I already showed, right? So first we need to use the output, right? The raw data. So the formula is, okay, I will copy this formula and then paste here, create the text. Because we use the function block, okay. So we need output, right? So I need to create the input. Input is the value that we key from the set point value, right here. So I need to use the input. It is the real, right? So input, I need to use the sub, right? Subtract. Example, set value, okay. And set value minus low scale, right? Example, low scale is 0.0, right? Let's see here. Low scale is 0.0 because we start from 0 to 100%, right? Okay. So we need to create the one more, right? Subtract between high scale and low scale. So I will use subtract between high scale and low scale, right? So high scale is with 100%, and it is the real, right? I will change the data type to real for set point value. And for subtract between high scale and low scale, so 0.0, it is the low scale. And then I will divide between this one and this one, right? So we can use divide between this one and this one. So let's use like this. It is the real, yes. And this one is the real also. I will use variable one and change the data type to real. And I will multiply by 16,000, right? So we can use multiply this one and this one Yes. Sorry. Multiply this one. Multiply by 16,000, right? 16.0. Yes. Okay, we can use like this. And then I will add by 4,000, right? I will use add. The check here is the data is real. So this one should be real. And this one should be 4,000. Yes. 0.0. And then we will got the value. Yes. But it is the real. So we need to convert to the integer, right? Because in the percent AQ1, yes, it is the integer, right? AQ1. So I need to convert from real to integer, right? So this one I will use var2. It is the real also, right? So I will convert from real to integer. Okay, I will do this one and then convert to integer. So it is the output value that it will control the val, right? So this one, it should be a percent AQ1. Okay, and this one should be percent R, right? Because we need to set point from the HMI. Yes. And for this one, connect with the AI2, right? AI2. So let's check the program. Okay, I will explain a little bit. Output, yeah, this one equal input minus low scale. So input it means that set point minus low scale, high scale minus low scale, this one, and then divide by this one, and then multiply by 16,000 and add by 4,000 and convert from real to integer, because this one is integer. Okay, so that's good. And we will download the program to the PLC. Okay, okay, click OK to download. So right now we set 0%, right? So 4 milliamp. Yes, right now the milliamp is show for also for multimeter. So we need to create the HMI. Okay, I will use the existing project that we already learned in the previous video, and then we will create the value, right? This one. So I need to create the person R. Yes. So create the new points. So right click, create the new points. Example, set value 1. It means that set or we can write SV control valve. Okay, and I will choose device. Yes, and choose analog, and it is the real, right? So I will choose real and person R3. Yes, person R3 and click OK. And we need feedback from the feedback from the control valve, right? So I will use AI1. So I will change this one to AI1. Okay, we can use AI2 because right now I already connect the loop control to AI2 and the scale is correct. So we can modify our screen, edit, and then start the project. And then we can delete this one. Yeah, the previous video. Yeah, no need. And I will delete this one also. So this one should be control valve. And we can also use the object. Example, control valve. Let's go to valve. Yes, here. We can drag and drop to use. Yes. So this one should be a set value, right? SV. This one PV. And I need to set point, right? Okay. Adjust a little bit to here. And then we need to put the unit also, right? We will adjust the control valve like this. Okay. Let me put the cover a little bit like this. and then I will change the color to be this color, and then send to back. Yes, and I will change this one to be white color. Okay, and we need to put the unit also, right? So percent. Okay, so we need to increase the size to be 20. Yes, and then we can save, and this one should be a set point, right? No sensor, so we can browse the points. Okay, browse the point. SV star. Okay, let me check the point. What is the point? SV control bar, right? Browse the points. To find the SV control bar. I will save the project first, and then stop and start the project again because it not yet updated. Okay, I will update and then start the project again. And then go to the screen again, edit again. SV style, right? Okay, this one. And I will use the set point accent because we need set point, right? And this one show the PV only. Yes. So we can take the screen, right? Okay, let's see here. Right now, if I set 10%, yes, the milliamp around 5.6, yes, and I will show the actual milliamp, yes, around 5.5 something. If I set 25%, yes, and if the feedback from the control bar, yes, it should be like this, around 8 milliamp, yeah, 25 also, yeah, 24 something. If this one I set 50%, let's see the milliamp around 12 milliamp. and this one should be feedback from the control valve 50% or so. And if I set 75%, 16 milliamp, and this one should be 16 also, right? Because actually the valve is open follow the milliamp that sent from analog output card. If I set 100%, 20 milliamp, and this one should be 20 milliamp also. Okay. So this is just instruction about how to use the scaling. Yes, create the scaling for analog output and input that we already learned. Yes, and I hope this video is useful for everyone. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I'm also sorry if I have mistake in this video also. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the software Proficy Machine Edition and Proficy Workbench to create the program and hardware configuration for the CPE 330 connect with the remote I/O. Okay. In the previous video, we already learned about how to add the remote I/O. Use only one remote I/O with 4 modules of digital input, digital output, analog input, and analog output. Okay. So today I will show and share about how to configure with 2 modules of remote I/O. With the remote I/O number 1, I will use digital input and analog input. And for VerSaMax or remote I/O number 2, I will use digital output and analog output connect to the port number 2 of CPE. Okay. And for port number 1, I will connect to remote I/O number 1, and port number 2, I will connect to remote I/O number 2. And for remote I/O number 1, I will keep the same as the IP address that we already learned in the previous video. So I just cut the 2 modules from the previous video, yes. And then I will adjust to be the same here. And for channel number 2 or remote I/O number 2, I will use the new one and need to set the IP address of this module also. Okay. So let's go to our software to hardware configuration and testing of this module. Okay. So first, let's open Proficy Machine Edition. And then I will use the existing project that we already learned in the previous video. Here is the existing project. So let's open. Okay, then go to the hardware configuration. For CPE, I will keep the same as the position because the hardware of the PLC, yes, I will keep the same slot, so no need to change anything. But we need to revise the remote I/O here, yes. In the previous video, we have 4 modules of I/O, right? So I will keep only 2, yes. The same as our slide, I will keep only 2 for digital input and analog input. So I will delete analog output and also delete the digital output. Okay. So I keep only digital input and analog input. Okay. For VerSaMax number 2, I will add more. Yes. Here. So to add the VerSaMax one more, I will delete this one first. Otherwise we will confuse. Okay. So this one keep only AI and DI, right? Okay, we need to use it because we will create more for VerSaMax number 2, right? So no need to delete. So to add one more VerSaMax remote I/O, yes, VS2. Let's go to right click and then go to add target and then go to add the remote I/O, right? So let's go to add the remote I/O. Yes, here VerSaMax Ethernet. Let's go to add target GE Intelligent Platform I/O. Yes, remote I/O, and then click VerSaMax Ethernet. Okay. If we use Profibus, we can use Profibus. Select the Profibus. Yeah. So right now I will select VerSaMax Ethernet. Okay. And I will put the name. Example VS2. Yes. Because VS1 we already use it. So I will add VS2. And I will put the IP address. Yeah. For IP address VS1 192.168.32.2, right? So here I will put 192.168.32.3. Yes. Because the hardware of CPE, right? Okay, this one. LAN 2 192.168.32.1, right? Okay. So we will start from .2 and .3. Okay, I will close this one first. And then go to config. Yes. So the spec of VerSaMax remote I/O is the same as the VS1. Yes. So we need to configure the network and add the module. So for network, I will start from 192.168.32.3. Yes. And for subnet mask is 255.255.255.0. And communication is EGD, Ethernet Global Data. So we must select EGD. And for produce exchange, yes, produce exchange, we can use the format follow the VerSaMax one. Let's see here. For produce exchange, we can use the consumer, right? Consumer IP address. It start from the CPE. So 192.168.32.1. Yes, because we need to produce from the CPE, right? And here is the exchange ID. Yeah, so we can choose one for exchange ID. And then we need to use the producer ID, right? Producer ID, it means that the Ethernet Global Data ID. Yes. So it will start from 10.0.0.0 here. Yes. So we can basically control C for copy. Yes. And then go to paste here. Yes. From EGD, Ethernet Global Data. And for group ID, consume produce, consume period, and update timeout, we still keep the same. Yes. Okay. And for memory, we cannot adjust, right? So we still keep the same. And we can save the project first. So we need to add the card, right? Add the module. So for remote I/O number 2, I will add digital output and analog output, right? So we can add it. So first, let's add the carrier box base. Yes, I will use this model number IC200 CHS022. Yes. And then we need to add the module, right, for digital output. So let's go to digital output. Yeah, discrete output. And I will use IC200 MDL750 32 bits. Yeah. And it will start from %Q1. Yes. And we need to add one more for carrier base. The same. Yeah. And then we need to add the analog output card right here. So we need to add the module and go to the analog output, and this is the model number. So we need to choose the model number, yeah, catalog number, the same as our real hardware. Otherwise we cannot test it. Okay, so be careful when we select the model number or catalog number from here. Okay, it will start from AQ, yes, AQ1 and 4 channel. So that's all for config the hardware, yeah, for this module. So we need to download, right? But before download, we need to set the temporary IP, yes, to be 192.168.32.3, right? So before go to set the temporary IP, let's go to set the manual IP address of our computer. Okay, I will change this one to 32 to be the same as the rank of the IP address that we want to set. Okay, and then we need to know the MAC address of this module, right? For this module, we already set it in the previous video. Let me ping 192.168.32.2, right? Let me disconnect the LAN, yes, cable, and then insert to the existing module. Okay, right now I already connected the LAN cable to the existing module. Let's ping again. So if we ping, we can get the reply from the module is okay, right? So if we ping anything for VerSaMax number 2, we cannot ping, right? Because we not yet set the temporary IP of this module. Okay. So let me connect the LAN cable to the VerSaMax number 2. Okay. And then we need to know the IP address, MAC address of the module, right? So to set temporary IP, let's go to right click and then go to offline command and go to set temporary IP address, and we need to fill the MAC address, right? Okay, let me show the MAC address. Okay, go to see the MAC address. Here is the MAC address of the module, right? So we need to know this one. So start from 009991. Yes. So we need to record the address. So start from 0099, then 101. Okay. 101. Yes. Next. 6005, right? Okay. 6005. Okay. Make sure the MAC address that we put here is correct. And then we need to assign the IP address here. So 192.168.32.3, right? Okay, and this is the IP address of our PC. So we can set IP and then click OK and wait a moment for this setting. Okay, it shows like this. It means that we can assign the IP address to be 192.168.32.3 successfully. Okay, then we can ping again. So 192.168.32.3. Okay. Okay, we can ping. And then we can download. Yeah. So right click and then select download to remote IO. Okay. And then click OK. So right now we already download the hardware configuration to the VerSaMax number 2 that we just created. Okay. So we need to download the program, yes, to the CPE also before test. So let me disconnect the LAN cable from this module to the CPE. Okay. Okay, so we need to put the manual IP address to be the same as the CPE for LAN 1, right? Otherwise, we cannot connect to the CPE for download. Yeah. So let's go to change the IP address of our computer. Okay, I will change to .0. And for this one, we no need to change, right? But we need to add more for VerSaMax number 2, right? For VerSaMax number 1, we have only digital input and analog input, right? Digital input and analog input. Okay. So we need to create more for VerSaMax number 2. So VS2 consume. Okay, I will delete this one first. So produce ID, it should be producer, right? So 192.168.32.3, right? Okay, .32.3 because for VerSaMax number 1 .32.2, yes. And for adapter, yes, it's the same because we connect with the slot number 1 or LAN number 1 of CPE, yes. Exchange ID is 2, yes. And timeout, yes. Actually, timeout we can set 603. This one 603 also. And for the run store mode, we can put true because we need to download. We need to add another card and download, but no need to stop the CPU, right? So we can select true. Okay, and we need to add one more for VS2 producer. Okay. And this one we can select unicast, and this is the IP address of destination. It means that produced from CPE to where, okay? So to 192.168.32.3 produce to the VerSaMax remote IO, yes. And here we can also select true for run store mode. Okay, and we need to add the format, yeah, the same as the VS1, right? VerSaMax number 1. So VerSaMax number 1 we keep only VerSaMax number 1 is correct, right? But the producer no need. I will delete from this one. Delete, yes, because we need to add for VerSaMax number 2, right? So I will add for console first. So double click, and then we need to add to be the same the consume of the VerSaMax number 1, right? So first we need to add the status, and then second we need to add the command, right? For status is 1 integer and command is 2 integer. Okay, so we can go to variables and then right click and then create new integer. So this one should be VS2 consume status. Yes, and don't forget select here CPE IO. It means that the project, and it should be 1 for integer. Another one, we need to add the consume, sorry, PS2 consume command, right? Then we need to add the 2 integer for command, yeah. And then we can go here and then click here for add. So first VS2 status, and then here we can add the VS2 command, yes, VS2 command. And then we need to add the IO, right? But for the consume we no need to add, because VerSaMax number 2 we use for produce only. Okay, DO and AO, so we keep here. And then let's go to VerSaMax number 2 for producer. Yeah, we need to add the producer. Let's see here the VerSaMax number 1 producer. We need also add the 1 integer for status and 2 integer for command. Okay, so for VS2 we need also add VS2 produce status. Okay, 1 integer and one more for VS2 produce command, yes, produce CMD, and we need to add 2 array of integer, yes. Then we can go to add, yeah, here. So here we need to add the VS2 producer status, right? Produce status here, and here we need to add the VS2 produce command. Okay, and then we need to add the IO, right? Because we need DO and AO. So click add and then add the digital output, yeah, here, and start from 1, right? And 32-bit. One more for analog. Go to analog output here, AQ, and then start from 1. Okay, and it is 4 channel, yeah, so forward. So that's all for configuration the EGD, yeah, for VS1 and VS2 produce and consume. Okay, so we need to download. Let's connect to the CPE. and then download the new program to the CPE. Yes, then I will try to plus also. Okay, then I will start the CPU. Yes, so right now it not start, right? So let me change the setting a little bit for here. Consume exchange should be 2, right? Okay, let me change to 2 and then go to the VerSaMax again, and then I will download the hardware config to the VerSaMax number 2 again. So let me change the IP address of computer to 32, and then I will disconnect the LAN cable to connect with this module again. Okay, then let me ping for check. Okay, we can ping. So I will download the hardware configuration again because I'm sorry because confused here. So we need to change this one to 2. For a change for VerSaMax number 1 is 1. Yes. So VerSaMax number 2 should be 2. Okay. So let me set the active target again and then download. To remote I/O again. Okay. Download complete successfully. So I will reverse the LAN cable to be the same position. And then I will set the IP address of computer to be the same position also. So .0. And then go to save the project and then connect again. And I will download again. Okay. And let's test together. Actually, we can stop the CPU and then download the hardware again. Because we change the hardware. Okay, and then we start the CPU. And I will show the status of the PLC. Yes. So let's check the default table. Yes. So right now we got data from analog input. Yes, because right now I already connect the loop calibrator to the channel number 1 of analog input. And this one is for because the existing video we create the program, yeah, for scale analog output, right? Yes, I think here. Yes, we use analog output. So let me show the status. Okay, let's see the status is on. Yes, here for VerSaMax number 1, and for VerSaMax number 2 also on. Yes, here. Okay, then we can test. Right now I already connected the push button for start and stop. Yeah, and the logic we already created in the previous video. Yeah, here. Okay, so when I push button start, yes, let's see, the input is turned on and relay is turned on also, because we already connected the output, yes, to here. Okay, and if we push stop, it will stop. Yeah, start again. Yeah, sorry, the button is not connect. Okay, start. The output is turned on. Let's see here. So we can also test the analog. Yeah, here. And right now I already connect the loop calibrator to this channel. Yeah, so we can adjust. Okay, let's see, the value here is increase. Yes. Okay, so it worked correctly. So for output, analog output, we can also test from here. Okay, if I set 100%, example 100%, we will got 20 milliamp, right? Okay, example 50%, we will got 12 milliamp. Yes, around 12 milliamp. So we successful configuration this module. Yes. So if we would like to test the control valve or some motor, we can also create. Okay, I will show. So we can use the existing project. Yeah, our project. Yes. We can run our project, the existing project. Okay, then we can set. Yeah, example, I adjust the control valve from here. Example, I will close 0%. Yes, right now the milliamp is show 4. Yes, around 4 milliamp. Let's see, around 4 milliamp. If I adjust to 25%, around 8 milliamp. Yes, 25%, around 16 milliamp. Yes, and 100%, it should be 20 milliamp. Okay, And for digital input and output, we can also create. Yes. So let's go to the main. Yes, here. So here we can also create the motor. Yeah. Example, start and stop the motor. So we can add the point. Yes. Example, I will create for start and stop the motor. Okay, start. I will use %M for start from the HMI. Yes. So I will insert this one. Start HMI. And for the reference address, I can use %M. Yeah, %M1. And for command stop, I can also use the NC contact. Stop HMI. And I can use %M2. Yes. And for digital output, we can also add more. Example, I add to until 8 bits. Yeah. So we can use coin. Yes. Coin for 8 bits. Can copy and paste until 8. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So here we can use M3 CMD, M4 CMD, M5 CMD, M6 CMD, M7 CMD, M8 CMD. Then we can insert the digital output, %Q3, %Q3, okay, %Q4, until %Q8, right? %Q5, %Q6, %Q7, %Q8. Okay. So we can delete this one. Okay, like this. And then we can save the project and then download the logic to the PLC again. No need to stop the CPU because we just modify the logic. Yes. Okay, right now it's on all because we push the button start, right? So let me stop. Okay, stop all. So we need to stop and start from the HMI, right? So I will add more for stop HMI. It is dy, right, and boolean, because we use boolean. So for stop, it stop from %2, right? So let's go to command stop from HMI. This one should be %M2. Okay, and we can duplicate for command start. So start from HMI, and this one should be %M1, right here. And we can change this one for command start from HMI. And then we need to show the status of the output, right? Example, motor 1. So we can duplicate. Example, motor 1 status. So %Q1, yeah, this one. So this one should be motor 1 status. Okay, and for motor 2 and motor 3 until motor H, we can also duplicate. Just change this to 2 and then duplicate. Change this to 3. %Q3 motor 3. We can do the same instruction until motor 8, right? So I will go fast because it's the same procedure. It is just example, yes. Actually, everyone can do any style, yes. Six, 7. Okay. 7 and 8, the last one, right? Okay. So we can create the new screen, or we can use this screen, yes. Edit. I will increase the geometry to be 1000. Okay, too big, right? Width maybe 600, and height should be 600. 400. Okay, like this is okay. This is the existing project. Yes, so we need to use the start and stop right button. Stop. I will use the color for red. Stop and copy one more for start. I will use blue color, and the text should be text color should be black, right? Okay, and then I will insert the motor. So let's go to the motor. Yes, we can use another motor that we want. Example, I will use this style. I will use this style, or this style. Yes, we can use another style that we want. Yes, many style that we can choose. So I will adjust to be like this for motor 1. Motor 2 should be like this. Then motor 3 should be like this. Okay, many style that we can choose. Motor 4, motor 5, maybe smaller than this, otherwise it's not enough. Or we can adjust the geometry a little bit to be 900. Okay. So we can adjust bigger than 1, 2, 3, 4, 5. Maybe adjust to 1000. Okay. Then I will insert more style of motor. Example, this style. Yes. Or this style. 2, 4. Okay, one more, right? I will adjust a little bit more. Many motors, right? So we need to put this one. Yes. Okay, I will adjust to be a range again. This one I will change to be this style. Let me choose again. Maybe I will use this style. Okay. Then we can put start stop here and control panel, control valve. Yeah, I will put here. Okay. Then we need to configure the start stop button, right? Okay, for stop button, let's go double click and then go to event and then choose the mount up, new procedure, new, and then choose the absolute set point. And we need to browse the point that we already created, right? So I will choose this. stop, right? We can search stop HMI and we can copy, yeah, Control C and add more for mount down and choose the new procedure and new and absolute set point again and paste and should be 1. Yes. For start we can also the same, mount up, new procedure, new absolute set point, and we can browse start and then start and choose browse. We got start HMI and we can copy and choose the new event, mount down, new procedure, new, and then absolute set point and paste and change this one to 1. So we can save and then test for start and stop. So if we push start, let's see, start, yes, this one on, stop, start, stop, start. Okay, so we need to show the condition of the motor, right? Okay, so we need to add the color animation for the motors. So I will use rectangle, yeah, to put here to change the color of motor, right? I will use none and normal is red. So we will change the color, go to color animation and then go to edit. So we can browse the point to be a motor and then start. And we can sort the motors, motor 1 status, yeah. So we can change the field to be green color, yes. When it 1 should be green. Just copy and then change only this one, motor 2, right? So we can change to 2, and for this one we can change to 3, this one we can change to 4, yes, this one we can change to 5, okay, 5, correct. This one we can change to 6, and this one we can change to 7, and the last one we can change to 8. Okay, that's all. So we can save and then we can test the screen. Let's see, here is the all motor is turned on, yes. So if I push stop, it will stop, yeah, together because we parallel with the output. And let me show the PLC is on and off also, yes, when we push start and stop. So let's see, the digital output is turned on 8 bits. So if I push stop, yeah, start again, stop again, start again, yes. So we can control from the HMI also for this video. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the PLC GE to control the motor step by step by timer, and those timer we can set point for start and stop for motor number 1 to motor number 8 that we already learned in the previous video. Okay, so in the previous video we already learned about how to hardware configuration to CPE 330 from VerSaMax remote I/O number 1 and number 2 by using the Proficy Machine Edition and Proficy Workbench. Okay, so today we will continue to create the logic for control the motors by using the timer. Okay, and for hardware configuration we will keep the same as the previous video for VerSaMax number 1 and VerSaMax remote I/O number 2. Okay, for VerSaMax remote I/O number 1 we have two modules of digital input and analog input, and for VerSaMax number 2 we have two modules of card also. The first one is digital output and the second one is analog output. Okay, and all this signal we already tested in the previous video. Okay, so today we will create the screen and create the logic for control the motor step by step by using the timer, and we can also set the value of timer from here. It means that we have time stop and time start for each motor. Okay, so let's go to follow me step by step with software Proficy Machine Edition and Proficy Workbench. Okay, so let's start. Okay, first let's open Proficy Machine Edition software. And then go to the existing project that we already learned in the previous video. Okay, and then go to the main program, right? Here. Okay, the previous video we create the output, 8 outputs from motor number 1 to motor number 8. Then we can start and stop from the Proficy Workbench and button start stop also. Okay, so today we will create the start stop sequence for these motors. Yeah, so I will insert the run more. Press Ctrl and R to insert the run. Yes. Then we can create, yeah, I will put the start and stop is the same position, but the output I will separate, yes. So when push button start, yeah, it will need the timer, right, to start the motor number 1. So let me insert, okay, I will delete this one first, keep only one person Q1, yes. So when start, we will let allow the timer, yeah, example timer sec, yeah. So we can command start motor with, or we can write start sequence. So when I push start, yes, yes, when we push start, I will use the auxiliary, yes. Example start CMD sequence, okay. Then I will hold the signal, okay, hold the signal. Then I will allow the timer, yes. So when this one on, timer will on, so I will use TMR sec, okay. Okay, TMR sec. So here we can put the PV, yes, process value. So we can put example, we need to set point from the HMI, right? So I will use the variable, example timer 1, or we can write motor 1, timer STM1, timer for start motor 1 set, right? Okay, we can use like this. Actually we can view and then full, yes. So timer for start motor 1, and here we need to put the name, yes. Timer M1 start, yes. Okay. And if this timer turn on, yes, this timer turn on, it will turn on the motor number 1, right? So this one I will keep like this for start and stop from the push button. Okay, and this one I will use the auxiliary example M1 ST. It means that M1 start. Then I will delete this one. So when M1 start, I will start the M1 CMD, right? Okay. And then hold the signal. Okay. So when we push stop, actually we can start and stop by one also. Yes. Example start auto or manual. But this case I will start by automatic first. Yes. So we need to put one more for emergency, right? Okay, we will create later. So this one for motor 1, yeah. Command start for motor 1. Okay, and then it will count to start motor number 2, right? So if motor 1 start, I will copy the timer and then like this. So I just change this one to M2. This one change to M2 also. And this one should be M2 start, right? Okay. And this one we can copy. For motor M2, right? So we can copy command. Okay, motor 2. And for motor 2 on, yes. M2 on. I will start the %Q2, right? For motor number 2. And I will hold the signal. Okay. And then allow one more timer so we can copy. Yes. And change this one to M3. Copy and paste, right? Then we can copy all, yes, and then paste. Change this 1 to 3. So this one should be M3, right? So we can copy and paste. Change this one to %Q3. Change this one to timer number 4. Okay. Number 4 also. And this one should be number 4, right? Then we can copy for motor number 4. Yeah. Actually, we can use another style of logic that we can use. Yeah. The result is the same. Yeah. If we write the correct logic. Okay. We do the same instruction until motor number 8. Just change the variable to 5. Yes. Don't forget change the name of timer, otherwise it will be a duplicate. So this one, motor 1, motor 2, motor 3, motor 4 should be motor 5. This one should be motor 6. Sorry, Control Z. Okay, we will change to motor 6. And this one should be start 6, right? Should be 7. Motor 5, yes, start motor 5. Then this one, timer for start motor 6, and this one should be motor 6. Yes. And we can copy more for motor 6. This one, timer 7. This one should be motor 6, right? This one, 7. can copy one more for motor 7. Motor 7. This one motor 8. Timer 8, right? Option Q7, and this one should be 8. So the last one we need to insert to rank more. Okay, and we can copy. Okay, so this one should be 7 and this one should be 8. So MH and no need to use the timer more, right? Because we just use only 8. Okay, and we need to stop one by one also. So when we can create the button stop. Yes. So NC M1 stop SP, yes. M2 SP. M3 SP. M4 SP. M5 SP. It means that M5 stop, pull button stop. M6. M7. And the last one for MH. Okay. So we can insert the %M more. %M3, %M4, %M5, %M6, %M7, %M8, %M9, and the last one for %M10, right? Okay. Then we will save the project and then download this logic to the PLC and then test first. Yes. And we need to put the %R, yes, for each timer. It is the integer, right? Okay, %R for set the timer. Okay. we create like this, we can set another %R for timer that we want. Yes, let's save again and then download to the PLC. Wait a moment for downloading. Okay, then we can start the CPU. So actually, if I push button start from the hardware, yes. Okay, let's see. It will start. Yes. Let's check this one should be M1 on and this one on. Then this one will on, right? Let me change a little bit. Yes, the logic is not correct. This one on should be this one on. Let me stop. Then we can stop one by one, right? Okay. So let's create the HMI for start and stop from the HMI. Yes. So first we can go to the text and create the text, right? And we run the project first. Okay, then we can dynamic and create the text. So first start sequence, right here. So %M2, %M1 we already created in the previous video, right? Let's check the start and stop. Here we already create in the previous video, so no need to create more. So we can create the stop from the HMI for motor 1 to motor 8, right? Okay. So example, I can dynamic from here. Okay, duplicate from here. Sorry. We can tie the M1 stop. So command stop M1 from HMI. So command stop M1 from HMI is %M3. So I will change this one to 3. And then we can duplicate sorry, duplicate M2 stuff, %M4, until the motor number 8, right? Stop %M3. Okay, let's check. Stop motor number 3, %M, %M5, right? Okay, let me check this one, %M4. This one should be M5, this one should be %M6, right? Okay, duplicate more for M5, M7, this one should be M4, M6, H, for motor M7, and the last one for command stop, motor MH, M10, right? This one MH. Okay, that's all. So we can go to the screen. Yes. Okay, we can edit the screen, the existing screen, right? So here is motor 1 until motor H. Yes. So we need to create the stop sequence and start sequence. Yes. So let me check the configuration here. Is correct, right? Okay, correct. So no need to create this one. Yeah. Then we need to stop the motor one by one also, right? Example, we can use the button for stop motor number 1. Okay, we can write stop. Adjust to be red, or this one should be like this. Okay, stop like this. Then we can copy to all motor. Yes, and then we can configuration to be event, mount up, new procedure, new absolute set point, right? And then we can browse the point, stop, start, M, right? M1 stop. Okay, and we can copy and then OK and create the new event for mount down, new procedure, new absolute set point, and then paste and change this one to value 1. Okay, then we can run the screen and then we can test. Let me test for stop. Stop the motor number 1, right? It means that stop this one. So if I push stop, it will stop, right? Okay. So we need to configure all the motor stop the same as this one, right? So I will delete this one first, then just copy and just change the procedure to M2. Yeah, this one to M2 also. This one for M3. This one for M3 also. This one for M4, so we can change to M4. This one for M5. This one for M6. Sorry. Okay, or the M6. And this one for M7. The last one for M8. Okay, then we can test. Save the screen and then we can test. If I push stop M8, okay, M2 is turned on, right? So if I click push stop, stop M3, stop M4, stop M5, stop M6 and stop M8. Okay, so we need to set the timer, right, for M1 to M8 for delay time for start. Yes, so we need to create one more text for each motor, right? So we need to set the timer on. Yeah, timer for start. So this one may be not used, so I will delete it from the screen. This one for start and stop sequence. Yeah, I will keep here. So we need to create the text for timer, right? take string for timer. $14, right? And the color I will use green. Okay, time start. So here we can write time start. I will arrange this one to be like this. Yes. And adjust the font size to be 10 for time start, right? And should be a timer for actual start, right? It count, yes, it will count, right? Actual time, yeah. And one more for stop, right? We can create to be ready. One more for actual. This one should be time stop. Actual time stop, right? Like this. And we can arrange this one to be like this. Okay. And we can select and then copy to each motor. Control and Shift, drag and drop, yeah, to copy. It is the basic of design the screen of simplicity, yes. Okay, and unit should be the unit should be second, right? Because we use timer sec. So I will change this one to be sec and then change color to be white. This one should be white also. Okay. Then we can copy the unit. Copy all unit to put of each motor. Yes. Then we can save the screen. And we need to create the timer, right? Okay, let's go to Tech and create more for timer setting. Example, the M1 set time start from version R5, right? Okay, so let's click new point. Example, M1 start set and it is analog, right? And choose the integer, yes. And here we can use the command, mention the command, example M1 start time set. So %R5, right? Okay, let's recheck again. %R5, yes, for motor number 1. Then click OK. And we can duplicate for M2, %R6. Start time set for motor M2. Duplicate one more for M3. 7. M3. Duplicate one more for M4. %RH. This one M4. We do the same instruction for M5. %R9. M5. For motor M6. %R10. M6, right? One more for M7. %R11. M7. The last one. No need to set, right? Because we have only H, right? Okay, we need to create one more for start for motor number H. So %R12. Okay. Then we can go to the screen and insert for setting here. We need to set, right? So we can go to the text display expression and browse the point to be M1 set time, yes. And we need to set the action, right? And here we can set to the integer, yeah, integer. No need to confirm, yeah. And for the actual, we will add letters, yes. So we need to add for motor number 2. M2. Change this one to integer. Actually, we can copy and paste like this. I will delete first. Copy like this. Just change this one to be take number 3, right? M3. It's faster than we create the new one, right? M4. M5. M6. M7 MH, right? Then we can save and then run the screen. Yes. So basically we can set, let me show the example. We can set example timer number 1. We can go to screen and then go here. We can set on our keyboard example 10 seconds, 10 and then enter. Yes, it will start every 10 seconds. Yes, so we can write 10 seconds or 12 seconds or 14 seconds or 15 seconds that we want. Yes, to set. Yes, so let's check our data that we already set here. Yes, 15, 12. Yes, and then we can start the motor. Yes, so if we push start sequence, right, start the sequence. Let's adjust a little bit for start sequence, right? Okay, if I push start sequence, let's see the timer is count, right? Okay, motor 1 is start, and then it will start motor number 2, follow our setting. Yes, start motor number 2 and then start motor number 3, follow our setting. Automatically start. Yeah, follow the timer that we set. Okay, so we can test until motor number 8, and then I will create the take more for actual time that count, right? Motor number 5 is running right now, number 1 until number 5. Okay, start motor number 6. Number 7, and the last one for motor number 8, right? Okay, so actually we can stop one by one, right? Or we can push stop sequence. Yeah, let's create the stop sequence. We can stop sequence, right? Okay, create the stop sequence. But I will use the timer, this one, to show on the HMI first. Yeah. So we can use the text more. Okay, so we can insert for timer to show on HMI. Yes. So let's insert the %R more. Yes. For each motor, for each timer. Okay, then we can save and then download. And then we need to create the point for show this data, right? Start from version S13. So this one example M1, we can duplicate from here. M1 time start status, yes. So M13, right? Okay, start from version R13. This one M1 start time status. Then we can duplicate for M2 14, right? M3 15. One more for M4 16. M5 17. M6 18. M7 19. And the last one, right? 20, right? For motor MH. So we can duplicate for motor MH. Version R20. Okay. Then we can browse the point, right? On text here to show the actual time. Yeah. So we can choose M1 here, status, and we need to show the integer, right? No need to set point. Yes, like this. And this we can delete and then copy from here. Just change the name to be M2. This one M3. This one M4. For M5. M6. M7. The last one for MA, right? Okay. Then I will change this one to emergency stop, yeah, for each motor, yeah. EM stop, yeah, for each motor. I will delete this one first, yeah. I will configure the button to be the same pattern, yes. Then I will modify this one for emergency stop, because no need to stop one by one. If we have problem, we can stop by emergency, yes. So I will change this one to toggle set point and M1, yes. So this one for M2, I just change to M2. Emergency for M3. Emergency for M4. Emergency for M5. Emergency for M6. Emergency for M7. And emergency for M8. Okay, motor number 8. Then we can save the project, and I will adjust this one to here, yes. So we can copy text here, and then we can write the title, start and stop motor step by step using timer. Then I will change the color, yes, change the font size to be 28. (72). Oh, so big, right? Let me adjust to be 36 as well, right? Then we can save, and then we can run the screen. So here we can push stop, yeah, one by one. And we can put the alarm, yes, for emergency here. So if we push emergency stop, it will alarm. So we can use this point to create the alarm. For blink, yes. So here we can use blink. Okay, we can test. So we can choose the color also, right, for blink. Example, blink for this color, or we can choose here blink field or blink line. Yeah, I can choose blink field with color, this color. Okay, let's check. Okay, emergency like this. So we can know if this one or the emergency, it will blink, yes, the alarm like this. So we can create the same as this method, yes, like this. Blink field with the color, yes. Example, we can change another color that we want. So this one we can go to config to all, yeah. We can copy from this text, copy, go to color animation and then edit, and then paste, and choose the blink, solid, and then choose the color that we want. This one also go to copy, go to color animation, and then blink field, solid, and then choose the color. Can copy from here, blink field, choose the color. I will go fast because it's the same instruction, yes. Everyone can follow me, yes, step by step. It is the basic design of HMI, yeah, for simplicity. So we can test. Okay, the last one, go to procedure, copy, color animation, and then paste, blink this color, yes, and then we can run the screen, yes. So if we not push like this, it means that not emergency, right? Push like this, it means that emergency, yes. And if we push like this, we cannot start, right? Because we already locked by emergency here, yeah, emergency stop here. M1 stop, right now it's not stop. That's why this one is on. Oh, it's still on for start, right? Then we push stop sequence. Oh, it have signal from the push button hardware, right? So if we not release the emergency stop button or stop switch, we cannot start, right? If we push start, we cannot start. So we need to lock here also for emergency. So if emergency stop is not released, we can write command for emergency stop. Emergency stop command. So if this one is not released, we will insert, yeah, this one is not released and this one is not released. This one is not released. M5, M6. Actually, until M, yeah, %M, we can write like this, %M7. %MH. One more, two more, right? %M9. And the last one for %M10. So we will use one more for auxiliary for emergency stop. It not released, right? If this one not released, then we will put like emergency stop. Then we will lock this circuit, yes. So we will lock here. Then we can copy to all the logic. Not allowed to start, right? Okay, like this. And we can test again. So we need to release the all emergency, right? Before start. Okay. Then right now ready to start. So we can push start. We can push start sequence, right? I will adjust this one to be less a bit. Example 3 seconds. Yes. And we can start sequence, right? Okay, start sequence. After 3 seconds, it will turn on. Yes. 3 seconds more, turn on. Yes. Turn on. Okay. Correct. So after that, we can use the stop sequence, right? It did program more for stop sequence. Example right now, if we stop, we cannot stop, right? Because we not yet config the program. Yeah. But if we push the emergency, which one that we would like to push, we can stop all the motor. Okay. Stop all because it's emergency stop. So we need to create the logic more for stop sequence, right? Okay, let's start. So let's create logic more. Okay, here we can write stop sequence. Okay, so we can create the logic for stop sequence. So I will use command stop. Maybe we can use from here command stop sequence, right? Okay, we can copy. And then we can change the logic to be NO. And I will use coil stop sequence. And then hold the signal also. Stop sequence command, right? I will change to command. Okay, so I will let the timer is count also, right? So I will use TMR sec. Yes. This one we need to set from the HMI also, right? So M1 or this one should be M8, right? Stop from motor number 8 to number 1. Yes. Start number 1 to number 8, but stop. We can stop number 8 to number 1. Okay. So we can choose MH. Stop set. This one MH SP stop T. Yes, stop time. And here we can use stop, right? So this one should be command stop of M8. So we can use M8 stop CMD. Then we can copy this one to cut this one, right? So NC. Okay. Then if M8 stop, so this one should be used NO. Then timer. TMR sec. Okay, I will insert run more because we need to modify the logic, yeah, for all motors. So when command stop of motor M8 is stopped, yes, then the timer is turned on, right? So we can use M7. here for setting. Basically we can copy and paste, change only the name to be 7. Right. So this one should be M7. So this one go to cut the timer for M7, right? Okay, this one you can stop this one. So NC. Okay, and one more for M6 we can also copy and paste. Change to 6. Then copy this one to stop the motor number 6, right? Here. We can do it one by one, otherwise we not confused. Otherwise we will confuse. So do it step by step. Okay, copy to cut the power of M5 here. And then we can copy and then paste. This one should be 5, right? This one should be 4. Also, and this one should be 4. And then copy this one to cut the motor number 4, right? Okay, here. Okay, and then motor number 3. This one should be 3. I'm also sorry, this video is maybe so long, but I would like to do it step by step for easy to understand. Yeah, because it is the basic. So we will cut motor number 3 here. For motor number 3, yeah, we can copy and paste. Change this one to 3. This one should be 2. This one should be 2 also. Okay, then we can copy and then go to cut the motor number 2 here. and the last one we can cut for motor number 1. Yes, so we can copy motor number 2, number 1, stop motor number 1, and stop motor number 1 also, and stop motor number 1, right? So we can go to stop motor number 1 here, and then we'll stop sequence also, right? Okay, we can stop here. One more, we can stop here. The last stop, right? Okay, can put here for last stop, and then we can save, and we need to put the timer setting, right? Because we need to set from here also for stop time and actual time. So let's go to put the %R for stop here. Yes. So %R, let's go to reference address and write % and then enter %R. Yes. So I will put this first. %R 21, 22, 23, 24, 25, 26, 27, 28, and then we need to show this status also, right? So %R also, %R, yes. Can put %R to be show the status, right? Okay, so it will start from %R 22, sorry, 21. So let's go to our text and then choose the command stop, right? So this one we can duplicate for command start set to command stop set M1 stop, yeah, SP for stop, and then %R 21 stop time, right? Okay, then we can duplicate more. M2, sorry, this one should be M7, right? I will change to M7 because we should stop from M8, right, to M1. This one should be M8. Then I can duplicate to be M8. And change this one to be M1, but let's see the M1 for stop set 28, right? Okay, so we can write 28, And for M6 can duplicate 23 M8 sorry M6 5 24 M5 M4 25 M4 for M3, right? 26 M3, and the last one for M2, right? Because M1 we already created. M2 we can use 27 M2, right? And this one we already created for M1 and 28. And we need to create the status also, right? From motor M8 stop status. So if we start from 29 for person I. So here we can duplicate SP, right? So 29 command stop status, right? And here we can duplicate for motor number 7 30. Okay, motor number 8, right? Number 8 we can change to number 7 30, right? Number 7 is %R30 here. So we can duplicate for M6 31 M6 M5 32 M5 M4 33 M4 duplicate for M3 33 M3 M2 35 M2, and the last one for stator, it should be M1 36 M1. Okay, so it will earn of 36. Okay, that's correct. So we can go to the screen and then create this one for setting, right? Okay, so go to the text expression, browse M1 for stop set, right? This one stop set, which one is stop set? This one, yes. And we can choose integer and set point action, yes. And here we can delete and then copy and change only name to be M2. M3, M4, M5, M6, M7, M8. Okay, and we need to show the status also, right? Okay, so let's show the status. Router point. So M1 status stop, right? This one stop. SP it means that stop. So we can show only integer, no need to set point action, right? Then we can delete. Then we can copy for M1, change to M2, M2 change to M3, M3 change to M4 for motor number 4, change to M5, change to M6, change to M7, and the last one change to M8. Okay, then we can save the project and then we can run, test run. Actually we can set here example 5 seconds, 6 seconds, 4 seconds, 10 seconds, 11 seconds, 8 seconds, 14 seconds, 13 seconds. Yes. Then right now we can start the motor, right? Yes. So let's go to see the logic is ready to start, right? I will online. And then download the new logic that we already created to the CPU. Then we will got like this. Okay. Okay, the data is okay. So ready to start, right? Here, ready to start. So if we push button start, let's see. Start sequence. Okay. Start. Okay, start sequence for 3 seconds. The output is turned on also. Okay, let me show. Yeah. So right now we can push stop, right? Ready to stop. So if I push stop, until 13, right? Let's see. It stopped, yes. And then count to stop the motor number 7. Okay. Stop number 7. And then stop number 8. Sorry, stop number 6. Follow our timer that we set. stop number 4 within 10 seconds here. Okay, stop. Okay, stop all, right? Okay, stop all. So we need to reset, right? If stop complete, we need to reset the command stop sequence, right? Otherwise we cannot start again here. Let's see, we cannot start again, right? So we need to stop it, stop all. We need to reset the command stop for stop this command, right? So we can put like this. So if the timer, this one is stopped, we need to stop all, right? So we can stop this one. Yes. Then we can start again, right? Let me download and then show the status on the PLC also when it starts sequence. Let's see it ready to stop or not. Sorry, ready to start or not. Okay, ready. So when we push start, it will start. Yes. So let me adjust to be like this. Okay, and then screen will put like this. So let me show the status when we start. Let's see the output. So if I push start sequence, the timer start count and the output will start step by step. Follow our setting. Yes. Let's see the output is turned on step by step. Until bit number 8, right? Okay, that's all. And if we would like to stop, we can stop. Stop from number 8 to number 1, right? Okay, stop number 8. Stop number 7. Stop number 6. Stop number 5. Then stop number 4. Number 3, number 2, and number 1, right? Okay, stop number 1. It is the last stop, right? So actually we can start up again, yeah, by pull this start up. So it will work again. So we can set the timer long or short time that we want. Yes. Okay. So easy to control if the logic is right. Yes, right by correct, so we can control the motor step by step. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And it is just basic for control the timer, yes, of motor. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will continue our lesson about how to create the new project and hardware configuration for connect with the Profinet remote I/O by using CPE 330. Okay, so I will use the Profinet scanner number 1 and number 2 for connect with the I/O module. Yes, and I will use LAN number 2. Yeah, there are two parts of LAN number 2. One part I will connect to Profinet I/O number 1, and the part number 2 I will connect to Profinet scanner number 2. Okay, and for LAN part number 1, LAN 1 I will connect to computer, and I will use software Proficy Machine Edition version 9.0 to do this project. Okay, and we will test with the real PLC after we make the hardware configuration. Yes, so let's go to our software Proficy Machine Edition and Proficy Workbench. So first let's open Proficy Machine Edition. And then create the new project. Project name is Profinet Scanner. Yes. And then I will insert the target. Yes. AR3i target. And target name I will put example CPE 330. And we need to put the hardware configuration, right? Okay, so first we need to configure the power supply. Right now I will use PSD 040. We must put the correct software and hardware, otherwise we cannot download. the program to the PLC. Okay. And for slot number 1, I will move the CPE to slot number 1 to match with my hardware. Yes. And then let's check the Ethernet. Yes, port. There are 2 ports, right? So the first one is LAN 1. So if we would like to enable the Profinet controller, let's see here is disabled, right? So if we would like to enable, let's go to double click on CPE. And let's check here. LAN 1 mode is Ethernet. LAN 2 mode is Ethernet also. So we need to enable Profinet. Okay. When we change to Profinet, let's see here, it's already changed for us. Okay. And for the LAN 1, I will put the IP address 192.168.0.100, the same as the previous video, 255.255.255.0 for subnet MAC. And for variable mode, I will use true. Then go to a terminal. Example LAN 1 CPE, and we need put 80 bits, right, for arrays. Okay. And we need to configure the target, right? Put the target 192.168.0.100. Okay. And we need to configure the Profinet controller with the Profinet Profinet scanner, right? The same as the picture, the slide here. So we need configure this port to match with this port. Okay. So we can go to property. Yes. And double click. Okay, there are no parameter here, right? So the first one, we need to put the variable mode. I will change to true. And go to terminal. Yes. There are 32 bits for this module. Setter address. Example LAN 2 CPE. .32 bits, right, for stator address. And then we need to insert the I/O device, right? Okay. So add I/O device. So we need to insert the PNS, yeah, Profinet scanner 001 to match with the hardware of PLC. Yes. There are 2 types. One type is PNS 001 and other type is PNS 002. Okay. So I will PNS 001. When we insert, we will got like this. Yes. And then for the PNS variable mode, I will change to true also. Double click to configure. and this one output stator and input stator, they are 64 bits. Input stator is 32 bits and output stator is 32 bits also. Okay, so example, I will map the address like PNS in, and I will put the 32 bits for array address, and for the output I will put PNS out and 32 bits also. Okay, and then we need to insert the one more power supply, right? So I will add one more power supply. Okay, and then we need to add the IO right here. There are two for PNS 001. Okay, after we insert the power supply, so we can add the IO. Follow our slide. Yes, here. So the first one is digital input, and the second one is digital output for node number 1. So we can add by right click here and then change the module list, and the first one is digital input, right? So let me go to digital input here and then choose the correct model that match with the hardware. Yes, so I will drag and drop this model because I use this model. Yes, and for digital output we can also drag and drop, yeah, here, and then click OK. So let's see the address. It will start from %I1 for input, and for output it will start from %Q1. Okay, so that's all for node number 1. So we need to add the node number 2, right? Because we have 2 nodes. Node number 1 is complete successfully, and node number 2 is will start to add, right? So to add the module number 2, let right click here and then add IO device, and we will make the same procedure. So let's go here and then choose the correct PNS 001 to match with the hardware. Okay, and then click OK. And for variable mode, yes, we need to put the same as the node number 1. Yes, so here I will choose true and double click to config. There are 60 bits, 64 bits also. Input is 32 bit. So example PNS2 in, and 32 bits for input status, and for output status is also 32 bits. Example PNS 02 underscore out, 32 bits also. Okay, I will change this one to PNS. So unmap and then map variable again. Okay, so that's all for variable mode. configuration. And then we need to put the one more power supply the same as the node number 1, right? So right click here and then change submodule and then drag and drop the power supply to slot number 3. We will got like this. And we need to add the I/O module, right? The first one is analog input and the second one is analog output. Okay, so let's right click here and then change submodule list. Right click here, change module list, and then go to analog input module. And right now I use this one, yeah, ALG264. So drag and drop to here. And one more for analog output module. So I will use this one to match with my hardware. And then click OK. And then we need to add one more for this option for analog input, because there are two options that we will use. The first one is 0 to 20 milliamp current, and the second one is 4 to 20 milliamp current. Okay, so right now I will choose change module, submodule, and then choose the 4 to 20 milliamp. Okay, and the address it will start from AI1 for input, and for analog output it will start from AQ1. Okay, so that's all. So we need to download the program to the PLC, right? Hardware configuration. But before download, let's go to check the CPU setting a little bit. Okay, this one always plus. Okay, run. Okay, and then go to memory. Okay, please go default first. So the first one, we need to put the manual of IP address of computer, right? Example, I ping 192.168.0.100. So cannot ping, right? So we need to put the manual of IP address of computer to be 192.168.0.253. Yeah, example. And then let's try to ping again. So we cannot ping. We can ping. Then we can online to download the hardware configuration. Okay. Okay, so right now we can online, and then I will clear the CPU first. Yes. Okay, and then we can download. Let me show the status after download. Let's see error, right? Okay, the Profinet, let's change here. The IP is the same, subnet MAC. So we need to change a little bit. For LAN number 2, right? Okay, I will change LAN number 2 to be like this. Example .100.1, because it cannot download when the IP address is the same rank of the LAN 1. Okay, so I will change this one to like this, and this one should be .100, right? This one also S7-100.3. Okay, and then save the project again, and then let's try to download again. Okay, we can download right now. Okay, right now we already downloaded the program to the CPU. Let's see the CPU status. Okay, let's see the CPU status. Right now it's stopped, right? So let me start it. Okay, right now the CPU start, but the Profinet IO, yeah, PNS, is not work right now. It's not connect, right? So we need to configure the IP address and device name for this module. Yes. So to configure this module, we need to know the name, yeah, of this module. Example, this name and this IP address for module number 1, and for module number 2, it this name and this IP address. Okay, and then we can disconnect first. And then let unplug the LAN card board from the CPU to plug on this module to set the IP address and name one by one. Okay, so let me unplug. Okay, and then we after unplug and plug to the module number 1 of PNS, let's go to tool and utility, and then click Profinet DCP, and then choose the correct LAN port and click refresh to detect with the Profinet scanner. Yes. If we cannot detect, let's check the IP address of our computer. Actually, we can change to auto and then detect again. And if we cannot detect like this, we can change to manual. Example dot 10. Yes. And then we refresh again. So right now I already connected the LAN cable from PNS001 on node number 1 to my PC. So we can scan again by click here and then choose the LAN. to scan, yes. Okay, we will got one PNS, yes. So we can put the name to be the same as the node number 1, yes, here. So we can copy here, Control C for copy, and then paste here for name. And for IP address, we can put 192.168.100.2 here, and then click the set device name and set the IP information. Okay, and then we can click again to make sure we put the device name and IP address is correct. Okay, correct properly. So we can go to unplug the computer LAN cable to connect with the module number 2. Okay, I will unplug from here and then plug to module number 2 here. Yes. Okay. And then we can scan again for set the module number 2. Choose the LAN, yeah, it is the LAN port. Okay. And then we can put the, okay, let's scan again. It should be another IP, right? Okay, so we can go here and then copy from here and then paste here and we can copy from here also and then paste here. Let's scan again. Okay, correct. So we can connect the LAN cable. Yeah, I will disconnect from here and then go to insert the CPE again. And then this cable I will connect to the node number 1. And this cable I will connect to node number 2. Yes. After that, let's see the status. Yeah, it connect like this. It means that communication between this one and CPU is okay. And this one also, yes. Let's see, the status is connect here. Yes. So we can test. After like this, we can test I/O. Okay, let me go to online. I will put this one to be the manual, the same as before, 192.168.0.253, and then we can download. Sorry, we can online. Yes, connect and online. And then we can go to the I/O, yes, table. We can create the new I/O table, example test. And for digital input, right, we can write %I1. Digital output is %Q1. Analog input is %AI1. And analog output is %AQ1. And let me test the digital input first here. So right now I already connected the push button from the digital input module to push button. So if I push button, let's see here, it works, right? And the status on the PLC is work also, yes. And for analog input, okay, I will adjust. Yes, let's see. If I adjust the milliamp, let's see the value of analog input is work also. And for digital output, let me force the signal. Example, I put 1. Let's see on. This one also. Let's see on. This one on. On. It's on. It's on. It's on. And it's on. Okay. And one more for this one. It's on also. Yes. So it works properly between CPU and remote I/O. Okay. So after that, we can create the program for control. Yes. So let's go to Workbench. Create this one more screen for control. Yes, to see the status. Create a new project. Example. Test I/O. Yes. I will choose the driver. Okay. Let's go first. And then I will create the new part. And create a new device, PLC1 or CPE 330, and the port is the master port 0 that we already created, and the IP address, yeah, 192.168.0.100. It is the IP address of CPE, right? Here, yes. So click OK, and then we can start the project. So I will release this one to be like the first 0 0 0. Okay, so if I push button, okay, on and off, right? And if I adjust the milliamp, yes, it will work also. Yes. So let's check the device is up, right? So we can create the points. We can dynamic. Okay, if I would like to create the start and stop for one motor, so we can create, yeah, for test only. So I can disconnect and then go to the logic, yes. Example NC con. Example stop NO con for start, and coil for motor, yes. So we can adjust. Okay, so I can hold the signal. So if the configuration is okay, we can create the logic for control via the I/O, yes. If this one okay, yes. So I will hold the motor one here. And then this one I will assign the address, example %M. And this one %Q1, yes. And then we can download the logic. Actually this configuration I already showed in the previous video about how to create the start and stop the motor, yes. In this section we just start to review, and for my focus is like this: set how to configure the Profinet, yes, scanner with the CPE. Okay, so we can go to the Workbench to create the point. Example M1 start, M1 stop, right? It is the boolean. M1 stop. So %M 1, right, for stop here, and for start is %M2. So we can duplicate. So %M2, and for motor 1, can use %Q, right? %Q1 here. Okay, and then we can go to screen and create a new screen. and we can adjust the geometry. Example 500. Okay, and then we can go to object and then insert the motor. Example, insert the fan or pump. Many objects that we can use. Okay, example, I choose one more pump or fan. Yes. Okay, and then I will choose the button for start and stop, right? I will use Vista, and the color should be red, right? Or this one should be blue, sorry, black, and this one should be okay, red. And I will copy for start, change this one to blue, and then change this button to stop, and this one I will change to start, and I will choose the this one to show the status of the motor, right? Okay, we can go home and enable this border snap to adjust a little bit. Okay, I will choose none for this color. So we will go like this, and then we can configure for button stop. Go to event and then go to the mount up, new procedure, new, and choose the absolute set point, and we can browse the points. Stop, right? And then we can copy and set value to 0 and create a new event for mount down. Mount down. Choose the new absolute set point, stop to be 1, right? So mount down is 1 and mount up is 0. Yes, auto reset. And for button start, we can copy and paste. Yeah. So mount up, new procedure, new absolute set point, and then browse the points for M1 start, right? And one more for new, mount down, create the new procedure, absolute set point, start to 1, right? Mount down is 1, mount up is 0. And then we need to show the status of the motor. Example, change color to be green for motor 1. Yes. So I will choose field and then choose green. Yes. And then we can test the screen. So example, I push start. Yes. It will turn on the output. Stop. Turn off the output. Start. Turn on the output. And let me show the status on the I/O. Let's see, the I/O is turned on. Yeah, output So if I push stop, it will off. I push on, it will run. I push off, I push stop, it will stop. Okay. And for analog input, we can also test and output the same, yes, as procedure. So thank you very much for watching my video, and I hope this video is useful for everyone to configure the Profinet scanner for two modules here, module 1 and module 2, for connect with the I/O module, yes, that we want. Actually, one node we can use the H I/O module, yes. So we add two nodes we can use for 16 module for I/O, yes. So it's very important for this step. So thank you very much for watching my video again, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about part 48, how to configuration hardware between PLC GE and PLC S7-300 by using the Profibus module. So here is the previous project that we already learned about how to create the Profinet I/O of PLC GE. Yes, Profinet 1, Profinet 2, and I will use one more for Profinet number 3 for config the Profibus master from PLC GE, yes, that link with Profinet I/O, link to the PLC S7-300, and I will link data from PLC GE to PLC S7-300 and link data from PLC S7-300 to PLC GE. Okay. So in this section, I will use two software. The first one is Proficy Machine Edition, and the second one is Schematic Manager. Okay. So before go to our software, I would like to explain a little bit about the concept. The concept is we would like to send the data, yes, communication data between PLC S7-300 with PLC GE by using this concept. Okay. And I have Profibus master of PLC GE, model IC200BE M003. It is the Profibus master. And for PLC S7-300, it is the Profibus slave. Okay. I will show step by step about how to configure the Profibus master of PLC PLC GE and Profibus slave for PLC S7-300. Okay, so let's go. First, we will configure the Profinet for this IO and this IO, and the second we will create one more for Profinet IO, and then connect with Profibus master to the Profibus slave of PLC S7-300. Okay, so let's go. Okay, so first open Proficy Machine Edition. Okay, I will start from config the first Profinet, the second Profinet, and the third Profinet for Profibus slave. Okay, so I hope this video is maybe long a little bit, but no problem. I will explain step by step about how to create. Okay, so right click and then create a new project. Example, I will put PLC S7, and then create the empty project. And I will add the target, yes, GE Intelligent Platform Controller, and I will use R3i, yes, to match with my hardware. And here I can rename the target name, example S7. Okay, S7 PLC, and then go to the enable the Profinet, right? LAN for LAN 2 of CPE. So let's go to LAN 2 and then enable the LAN 2 for Profinet. And then I will configure for power supply of my rack. So right now I use PSD040. And for CPE I will use slot number 1. So drag and drop to slot number 1. And then I will configure the LAN port for connect communication with my PC for online download and upload. So let me choose true for variable mode. And then go to configuration. And here I will use 192.168.0.100, the same as previous project. Subnet mark 255.255.255.0. And for terminal, I will map with the variable, example CPE ETM 8 bit, right, for status address. Okay, 80 bit. And then for target address, I will put 192.168.0.100 because the previous video we already learned it. So maybe I can ping. Let me test. Okay, we can ping. It means that we can communication between our PC to the CPU. Because right now I already turned on the power and connected the LAN cable from my PC to the CPE. Okay. So let's go to the Profinet controller configuration. Yes. The first one, we need to configure the variable mode to true. And for the LAN 2, we need to put the IP address to be not the same with the LAN 1, right? So the IP address of LAN 2, I will put example 192.168.100.1, yes, and should be changed this one also .100.1 to 100.254, okay, and click create, and then we will insert the Profinet scanner, right? Let's save the project first. So to create the Profinet scanner, yes, here Profinet scanner number 1 here, DI and AO, yes, and AI and AO, DI and DO, yes. So I will create the module number 1 of PNS. So let's go to add, right click, add IO device, and then go to PNS 001, the same as the catalog order number. Okay, after that let's go here and then choose the create, and the IP address will rank automatically, yes, and the device name will create also. Example, I will put this one to PNS1, so this one will change automatically. Let's see here. Okay, and the IP address is 192.168.100.2, okay, for module number 1, and we need to create the this one. We will create the power supply, right? Add the power supply, but before add the power supply, let's go to variable mode and choose choose true, and go to configuration, and we need to map the variable, right? Example, PNS1 it means that input, and we use 32 bits for input status, and for output also the same. So PNS1 underscore out, and we need 32 bits also for output status. Okay, and then we need to add power supply, right? One more. Okay, and then we will add the IO, right? The first one is DI, right? DI here. So to create add the DI, let's click here and then change module list, and go to the discrete input module and choose the module that match with the hardware, yes, and one more for digital output, yes, and then click OK and save the project. So for digital input, it will start from %I1. Digital output, it will start from %Q number 1. Okay, so that's all for module number 1, and the next we will create the module number 2, right? Or we can create the module number 3, but for the step we can create module number 2 first. So let's go to add IO devices, and then go to PNS 001, and this one we can change to module number 2, yes, it will change automatically, right? if we put like this, and we can create. And the same procedure, we can go to add the power supply. Sorry, can add power supply, right? Change this one to true first, and then go to configuration, and we can map the variable PLS2 underscore in 32 also, and one more PLS2 underscore out 32 also, yes. Add one more power supply, and then we need to add the I/O, right, for analog input and analog output. Okay, so let's right click and then change module list, and then go to analog input. Right now I use ALG 264, so drag and drop here, and then one more for analog output, ALG 331. And then for analog input, we need to change the sub module. Right now I will use 4 to 20 milliamps, so drag and drop. And for analog input, it will start from %AI1, and analog output, it will start from %AQ1. Okay, it is for channel. So that's all for module number 2. And the next step, we will create for Profibus, right? Profibus master here for link to the PLC S7-300. So let's go to create the module number 3. So right click here, I will minimize this one. Right click here and then add idle devices, and go to PNS001 again, yeah, and then click OK. And we can change this one to number 3, right? PNS number 3. Sorry, I will copy this one. PNS1, PNS2, right? And then change to PNS3. Yes, like this. And then I will create. So the IP address of this module is 192.168.100.4. And let's go here and then choose true, the same as procedure that we already created with module number 1 and number 2. So this module, we do the same procedure. So example PNS3 in 32 bits, and for out PNS3 underscore out 32 bits also. Okay, and then we can add more for power supply. So right click and then change okay, right click here and then change this one, and then insert one more power supply. And we need to add the Profibus master, right? Okay, this one. IC 200 BE AM003 Profibus Master. So to create Profibus Master, let's right click and then change module list, and let's go to bus controller here, and we will see the BEM003 Profibus Master. Okay, so drag and drop here to the list and then click OK, and we can change the data address this one to automatically. Yes, just click auto. Yes, automatic, and then we will add the slave, right, slave file for the PLC S7-300. Yes, here. So in this step we need to use the GSD file. Yes, here, otherwise we cannot use it, so we need to use this file. Yes, use this file, GSD file. So let me insert the Profibus slave. So right click here and then add slave, and then choose the model address, model number of PLC S7-300. If we don't have this file, we can have this, choose have this, and then to browse the file that I already show here. Yes, from this file. So let's add again, add slave, and then choose the file. Yeah, this one for Profibus slave. Yes, and then we need to put the address that we want. Example, in this step I will choose address number 5. Yes, we can choose another address that we want. Yes, and here I can add, yes, first general ID, second general ID, and third general ID, and the next we can add the data, yeah, that we want to send to PLC GE. Yes, example, master I, slave Q, 8 byte. Yes, we can choose this one, and one more for feedback. Yes, or control to PLC GE, I can use the master Q. It means that PLC GE is output and PLC S7-200 300 is slave. Yes, so we can choose like this and click OK. We will got like this. Okay, so the address will start from %I161 and %Q it should be 49. Yes, okay. So we can download this project to the PLC GE. Yes. So let's save the project and then connect and then download. Okay, I will stop CPU first because we must download the hardware configuration. Okay, let's see what is the error. I/O memory without. Okay, so we need to put the memory of CPU. Okay, like this, otherwise we cannot download. Okay, and here we can increase also, example 500, and then we can download again, try to download again. Okay. After download, we will set the name of the Profinet again, one by one. Okay, so I will start the CPU. Yes. I will show like this, easy to see the status. Okay, so we can minimize. Okay, right now the CPU is running. Yes. So we need to create one by one for the Profinet, right? We can change the name and IP address follow this step. Yes. Okay. So the first one, I will change the IP address of PNS number 1 to 192.168.100.2. Yes. So let me scan to see or not. Let's scan. Let's go to tool and utility and then choose this one and choose the LAN and then scan. If we cannot scan, we can connect the LAN cable directly to the PNS. Okay, right now we cannot scan, right? We can see only one for PLC S7-300 because right now I already connected the LAN cable to the switch. So let me disconnect and connect to the PNS directly to set the IP address and name. So the first one, let me connect to the PNS 001. So number 1. Okay, let's scan again. Let me show. Right now I already connected the LAN cable from my PC to the PNS 001 number 1. Yes, let's see here. I already connected the LAN cable to this port. Yes, and the status is not yet connected, right? So let's scan together. Go to the utility and then click this one and then scan. When scan, let's see the blink for LED. So right now we detect, yes, it detect one for this PNS. So let's check the name should be like this. So I will copy, yeah, Control C, and then double click here, then change the name to this one, and the IP address is correct, so we don't change. So set only name, okay, and then click exit. So we scan again. To make sure that we change is correct, yes. So let me show again. So I will disconnect LAN cable from this module and then connect this cable from the CPE, yes, to this module. And then let's see the status now is connected right here. Okay, connected. So let's go to module number 2 here. So I will disconnect the existing cable. Yes. And then connect the PC cable to this module. And then let's scan again. Okay, we will detect one. And let's check the name. Should be like this. Copy and then paste. So paste here. Okay, no need to change anything because the IP address and name is already set. Okay. So I will connect the LAN cable from the CPE. Yes. So let's see right now the status is connect also. Yes. So we have the last one for Profibus, right? So let me disconnect cable from the computer and then connect to this port for set the IP and name also. Let's see right now I already connect the LAN cable from my PC to this node, and then let's click here and then refresh again. Okay. Okay. The IP address is wrong, right? So we need to go to this module and then copy, right? Copy and then paste here. And the IP address should be changed to 4, right? So 4. Set the IP. Set the name. Okay, and then exit. And then let's confirm again for scan. It will change to 4 and this one change to 3, right? Okay. So we successful change and then exit. And we can disconnect the LAN cable from this module and then connect to our computer back, because we already set the name and IP address. And then let's connect the LAN cable from the node number 1 to this module. Okay, I will connect. And then wait a moment, it will connect. Yes, if the communication is okay. So we can go online our project. Okay, and then let's go to create the project for PLC S7-300, right? Forgot and send data to PLC GE. Okay, then create a new project. Example link to GE. Yes, link to GE. And create a new project. Example link to GE. And then choose the folder that we already created on desktop. And insert the new station for PLC schematic S7-300 station, right? We can write link to GE, yes. And then we can insert the rack. Okay, insert the new rack. And choose the CPU. Right now I will use CPU 314C 2PN/DP to match with my hardware, right? Okay. And here is very important, yes, for setting. The first one is IP address. We can connect with our PC to download and upload the project. And the second one, we need to put the Profibus for communication with the PLC GE, right? So we need to put the Profibus. So let's click here and then click new and click OK. Sorry, we can delete first and then click OK first. Yeah. And then go to setting here, right? Sorry. Go to MPI-DP, double click. And then choose this one to Profibus. And here is the address that we need to put, yes. The match with the address of PLC GE that we already put here. So the address is 5. Let's see here, 5. Yes, station 5. So here we can choose the station 5, address 5 also. Yes. And create a new for Profibus and choose the 1.5 megabyte per sec and DP, and we can click OK and go to property, yeah, to check and click OK. And then go to address, yeah, it is the default, yeah. For this tab operating mode, we can setting to DP slave, and the address is default, yes, use default. And for configuration, we can create the data that want to send and want to receive from PLC GE, right? So the data is should be made with this one. Example, here is the master from PLC GE is input slave, right? Because master slave shoe, sorry, master I shoe slave, it means that master is input and slave is output, right? So we need to create the output first for this step, right, of PLC S7-300. So let's choose new, and it is the output, right? Because the GE is input, so slave is output. Okay, so let's select output, and the address should be automatically created. So the length is very important. So the length of PLC GE is 8 byte, right? So here we can choose 8 byte, and consistency we should choose all, okay, and then choose OK. And we need to add one more, right, for this data, because we have two data that send and receive from PLC GE. So the PLC S7-300 should be add 2 also, okay. So master Q slave I, right? So slave I means that input and 8 byte also, and choose all, okay. So output it will start from Q 0.0 and I 0.0, okay, 8 byte. So click OK and then save the project. And we need to download the project to PLC S7-300, right? So let's click OK, download. Wait a moment for detect the CPU. Right now I already connect 192.168.0.1 for CPU of PLC S7-300. So we can ping, then wait a moment for detect. It will automatically detect. Oh, I forgot insert one more for analog. Yeah, the same as the previous video. So let me insert one more. Otherwise it will error, system fault if we download. So it is the existing project. So let me add one more for analog input. 7KF02, yes. Input type I will change to resistance for channel number 1, and for channel number 2 is 0 to 10 volt, and this one 4Y 2Y transmitter we already learned in the previous video. So let's save again and then download again. Okay. After that, start the CPU. Yes. Then we need to create the logic, right? So right now we will send the command from the output from PLC GE, right? Example Q person Q49. Yes. So let's go to create the logic. Or we can test directly. Okay, let me test directly first before create the logic. To test the address directly, let's go to reference table. And create the new table, example link to S7. Double click here, and then it will start from person Q49, right? For link data to PLC S7-300. So example person Q49. Okay, so we can test by forcing the signal from PLC GE and let online the PLC S7-300 to check. Example, I will check with the address. So it will start from, okay, I will zoom like this. Easy to understand, yes. Okay, like this. And PLC S7-300, let's see the hardware configuration again for the address. So the address for input is I0.0, right? So we will start from I0.0. Yes, I0.1. And then we can online, right? So if I force signal from PLC GE, let's see the input is turned on PLC S7-300, right? Okay. Let me arrange a little bit for easy to see. So if I force signal, point number 2, yes, until I0.2, I0.3, I0.4. Okay, this one I0.3. Yeah, we can test only 5 bits, so we will know. Okay, I will force more for this signal. Bit number 3, yes, turn on. Bit number 4, bit number 5, yes, it will turn on. So if we would like to force the signal from PLC S7-300 to PLC GE, we can force also. Because I will show the network is communication correctly, right? Let's see the communication is work correctly. Yes, for Profibus master and Profibus slave. Yeah, and the CPU is running. Yes. And then we can for the signal. So let me check the input, right, from PLC GE is start from input board. So master in, right? So input 161, yes. So here we can choose option I 161. And for the output of PLC S7-300, start from address. What is the address? Q0.0, right? Okay, so I can write Q0.0. Sorry, here. Q0.1, Q0.2, yes, example Q0.3, and then we can for the signal also. I will write through. Let's see the bit of PLC S7-300. Sorry, PLC GE is turned on. This one also true is turned on one more. True is turned on one more. And true is turned on one more. Okay. So it worked correctly. So the next step we will create the logic, yes, for start and stop from the PLC GE and then show the status on the PLC S7-300. Okay, so right now I will remove this one first. Set to 0, set to 0, and this one I will set to false. It false also, right? Okay, good. So I will create the new logic for control the PLC S7-300 and then let me show the status when we push the button. Okay, I will offline first and then create the sample logic for start and stop the motor control to PLC S7-300. So let's go to main program. Yes, I will create the sample example command control motor to PLC S7-300. Okay, and I will choose NC. It is for stop. NO. It is for start. And motor. It is coil, right? Motor 1, yes. And I will hold the signal. So NO. And then hold the signal for motor number 1. Okay. And here I can choose the %I. Yes. Example, the slot number 1 of this module. It starts from %I1, right? Here. So here I can choose %I1 for start. And stop is %I2. And for motor is %Q that link to the PLC S7-300, right? So master Q slave I, right? So here should be master I slave Q. So %Q 49, right? Okay. So I will choose %Q 49. Okay. And then I will show the signal that feedback from the PLC S7-300, right? So we can command show the signal feedback from PLC S7-300. So this one should be NO, right? Example feedback from PLC 300 is sent from PLC to %I, right? So it will start from %I 161, right? Okay. So example S7-301. Okay, so we can choose the %I but before choose I will create one more variable. Example, receive bit 1. Example, I will show the status. Example, show on the simplicity as S7-300 bit 1. Yes. So this one should be %I, right? 1 set 1. Yes. And this one should be %M. Example, %M. So we can download the logic to the PLC. After this one, I will create the SCADA, yes, and WinCC to simulation, yes. So right now, if I push button, yes, I will show the status of button. If I push button start, let's see the motor is turned on. Push the button stop is turned off. Yes. Start again, it's turned on. Okay. And then we can go to PLC S7-300 to create the logic also. Yes. So this one we can command got data from PLC GE. Example, bit 1, right? Bit 1 is I 0.0, right? Right now it is on because the motor is turned on. Yes. Here is on. Yes. So we can write like this, I 0.0, and then turn on. Example, turn on Q. Let's see the Q of hardware. It will start from this one, right? Output 136.0, right? So Q 136.0. Okay. And then if this one turn on, it will feed back to the PLC GE, right? So let me insert one more. So to feed back to PLC GE, let's choose the Q 0.0, right? So Q 0.0, okay. So we can save and then download the logic to the PLC, and we can online, yes. So the motor is turned on, yes. Let's see here. Okay. I will minimize this one first. So if I push button stop, okay, motor will stop. Push on again, motor will on again, okay. And then we can create the WinCC flexible to show the status from PLC GE and use the Proficy Workbench to create the SCADA. Yes. The first one, I will create the SCADA first. Okay. So let's go to Workbench. And then create a new project. Example, create a new project. I will choose this try. example GE S7, yes, and choose the driver protocol, yes, and go first. And then we need to create the port, right? So new port number 0, right? I will change this one to 1 second and go to device, create the new devices, example PLC 1, or we can write S7 1, and 192.168.0.100, right? For the CPU, yeah, this one, yes, and then click OK, and then we can update the project and then start the project. To see the status of device up, and then we will create the VerSaMax flexible to start and stop and show the signal with the simplicity, right? So let's check the device. Okay, right now device is up, so we can create the new text, right, for start and stop. Example here we can use parallel with start. Example start HMI. It means start from the simplicity, and we can create one more and see contact for stop HMI, and we can create the %M, create the %M also, and then save the project and then download the logic to the CPE. Okay, so start %M2, right? So let's go to points tab and then create the new text. Example start HMI. So I will choose device and then choose the boolean because it is on and off, and %M2, right? This button, and one more for stop, right? So we can duplicate and change to %M3, this one, and then we can use the %M1 also to show the status from the PLC S7-300, right? Example S7 status. So %M1, okay, and then we can create the screen. Yeah, go to new screen. I will insert the motor or pump one. Yes, example I will create the pump one or motor one. Yes, let's see the motor one. Okay, we can change to motor 1. Okay. Then we can go to the button. Example, this one for stop. So color should be red, right? And copy one more for start. It is the green, right? Start or blue. And the status of the motor, right? So we can use status. The motor is like this. So we can go to color animation, right? So we can browse the point as event status, right? Okay. And then change this one to fill to green. So if the event status is send signal, it will show green. If not send, it will show red, right? Okay, and then I will choose the string example motor 1. Change to be color, sorry, this color, and for font I will use the Tacoma bold and then 18, or we can increase a bit. Okay, like this. And we can save the screen, example screen 1. Okay, and then we can simulation, yes. Right now the motor stator is turned on, right? Okay. And then we can configure the button also for start and stop. So this one should be even. Go to the mount up, new procedure, new absolute set point, the start, right? Start HMI to 0. And one more for mount down. Absolute set point, start HMI to 1, right? And for sorry, this one should be stop. Confused because it is the stop button, right? So stop HMI. And this one stop HMI also. And one more for start. We can go to event again. Choose the mount up, new procedure, new absolute set point, and then choose the start. Choose the new mount down, new procedure, new absolute set point, and then choose the point start and change to 1, right? On. And save the screen again. And then we can simulation again. Okay. So if I push stop, it will stop. I push start, it will start. Okay. And we need to create the project of WinCC flexible also, right? To show the status of motor. Example, we have if we have HMI, so we can show the HMI also when the GE PLC is transfer signal data from this button. Okay, so let's go to the schematic. I will choose this one, the same as the previous video. And then go to connection. Yes, example GE S7, and I will choose the Ethernet. So this is the IP address of computer, right? So 192.168.0.253, right? So let me check to confirm again for my PLC, my PC address. So 192.168.0.253, that's correct. And for the IP address of PLC S7-300 is 192.168.0.1. Okay. And then we will create the text for show the status, right? Here. So Q0.0 is the status. Yes. Or Q 136.0 is the status from GE, right? Or we can write I 0.0 also. Yeah, the same. Go to the text and add example GE data bit 1. So it is the boolean, right? And I 0.0. Yes. And can go to the screen. I will change the screen to, okay, we can use the color. And we can go to see the status of the motor also, right? Go to graph and then insert the motor. Okay, let's go to find the motor or pump. Yes, that we want. Example, we can use the motor. Yes, here. Big motor, right? Okay. Then I will go to the object again and choose the text file. Example, status motor from PLC GE. Go to property, go to layout, and then uncheck this font so we can change font to be 24. Yes. Okay. I will use ball. Okay, and then I will change the color to be yellow or blue. Okay, and then I will copy format this one for motor one. Okay, for motor one. And for the status, I will use the rectangle also. The same as the PLC GE, right? The GE faceplate. So I will change to red color and then go to color animation. Yeah, to change. if the stator is changed from the PLC GE, right? So bit 1 go to here, and if the value is 1, should be change the background to be green, right? Then we can save the project and we can go to desktop. Okay, with the HMI example GE S7 part 1. Okay, and then we can simulation. Yes. Okay. So if I pull button start from the simplicity, yes, screen, start. Let's see the signal on the PLC S7-300 is changed also. Yes, the logic is work correctly. Yes. So if I push stop, or if I push start stop from the hardware button, let me show. So if I pull button start here, yes, let's see the status on the screen work also, and the output on PLC S7 is turned on also. So if I push start, so sorry, if I push stop, it will stop. Start again, it will start again, right? So the communication between Profibus master, yeah, here, and Profibus slave here is work correctly. But here is very important, should be select to off, and this one should be select to off also. Yes. Okay. So this is the part 1 about how to link the data from PLC S7-300 to PLC GE by using the Profibus slave and master. Yes, make together. And I will have the part 2 also about link the analog. Yes. The part 1 is only digital, and for the part 2 I will link more for analog signal. Example, we can set point from PLC S7-300 and got data on the PLC GE. Yes, so we can do also. So this is very important if we have many signals that would like to link from PLC GE to PLC S7-300 or PLC S7-300 to PLC GE. So we just run only one cable, Profibus cable, so we can link, yeah, and then we can control the process by using only one cable of Profibus. Okay, so this is a benefit of link between Profibus master and slave from PLC S7-300 to GE. Okay, so thank you very much for watching my video, and I will have part 2 also. Yeah, so please follow up for me. So in this time, I would like to say thank you very much again, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will continue our programming that related to PLC GE, and I will use software Proficy Machine Edition and Proficy Workbench connect to the CPE 330 to solve the problem of question that comment in the previous video. Okay, so here is the command, so we will write the program follow this step that he want. So the first one, I would like to read the command step by step, and we will create the program follow his command. Hello, I have one PLC question. Can you help me if I couldn't do the question? Thanks. In one system, one button, one start button and one stop button. So there are three buttons. One button is selection, and one button is start, and one more button is stop. Okay, so we will create three buttons, and then let's continue. So one is three-phase asynchronous motor. So example is the asynchronous motor. And in different system, the motor will be operated periodically in the forward and backward direction according to the follow principles. Okay, so the motor will start forward and backward automatically follow the principle. Okay, so when when button A is pressed one time, so if this one pressed one time, example mode 1, the system will be activated, and when start button, the system will activated. Example, I write mode 1. And when the start button is pressed, and when press start the button, so the engine will start in forward direction. Okay, so the motor will start forward direction. After 10 seconds, the motor will automatically stop, right? After 6 seconds, it will be work in reverse direction. So after stop 6 seconds, the motor will start automatically. And it will work in the reverse direction. Automatically start for reverse. After 10 seconds reverse running, the engine will automatically stop. Okay, after 10 seconds more, the motor will automatically stop. After wait 6 seconds, it will work the forward direction. The process will be continue periodically until you press the stop button. Okay, it will work forward and reverse and stop until we press button stop. The system will be cut off or will be stopped. Okay, and the system one signal lamp will be lit. Okay, and we will show the signal here. It will work in the forward. Please write the required program. Okay, and the step 2 and step 3 is the same, but the timer is not the same. Okay, so we write only one program, and then when we select, we just change the timer, so we can use the step 2 and step 3. Okay, so first I will show the simulation that I already created, and then I will write the program step by step, follow this command. Okay, so let's go to see my simulation first, then we will create the program together step by step, follow this required. Yes, so let's go. So first I would like to simulation the software. Yes, Festo plus sim. Yes, so here is just example. Example is a forward motor, forward direction, and here is just reverse direction. Okay, so when we push start, motor will run forward, right? After 10 seconds, the motor will automatically stop, and after 5 seconds, sorry, 6 seconds, motor will automatically run reverse, and after that, motor will stop again, and then after 6 seconds, motor will run forward. Okay, so we can start and stop. Yeah, after we stop, it will stop, right? Okay, so we can use this concept to apply on PLC GE. Yes, like this. I will test. So here I already create the logic. So we can select for mode 1, mode 2, mode 3, and then we cannot select more. And then if we would like to select, we can clear the selection. Example, activate 1. Yes, so we can start. So I will use forward and reverse signal to show. Okay, I just simulation first, and then we will write the program step by step. Follow me. Example this one, and we need to show the signal of activate 1, activate 2, and activate 3, right? Okay, I will go to data monitor. So this one is forward signal, reverse signal, and here is the activate 1, here is the activate 2, and here is the activate 3, but the color is white, so I will insert one more and then delete this one. Okay, so the first one we can select the mode, right? So if I select the mode 1, yes, mode 2, mode 3, yeah, the signal is activated, right? If I clear, it will off all. Yes, and if I select mode 1, example, I select mode 1, the mode 1 is activated. Yes, yellow color. And if I would like to start, I can press start. Yes, the motor will run forward. Yes, and the signal is show forward. Yes, after 10 seconds, right, the motor will stop, and after 6 seconds, the motor will start reverse, right, automatically. Yes, start automatically and stop. Okay, stop after 10 seconds. Yes, 6 seconds, the motor will run. Yes, start run forward again. After 10 seconds, yeah, the motor will stop, and after 6 seconds more, motor will start reverse, yeah, automatically. Okay, So if we would like to select to mode 2, yes, it will change the timer automatically, right? So I will stop, yes, and then we can change to mode 2, right? Okay, let me change to mode 2. So if I change to mode 2, the mode 2 will be activated, right? Activated signal is changed to mode 2, yes, activate 2. So if I start, the timer will change, right? The mode 2 is the period, right? The period of mode 2 is 15 seconds, 7 seconds, right? Okay. So if I press start, yes, the mode 2 is turned on. The motor will run, is running forward signal, and the timer is changed, right? Let's see. It longer than before, right? For start, forward, and reverse. Follow timer that we already fixed in the program. Okay, I will adjust like this. Easy to see. We can also change to 500. Yes, easy to see the signal. Run forward. Let's see here is longer than the mode 1, right? Okay. So it will continue start and stop, forward and reverse automatically. Follow the timer, right? Okay, so if we would like to change the mode, we can stop and then go to mode 3. Yes. So for the mode 3 is 20 seconds for running and stop 5 seconds, right? Okay. So we can start for mode 3. So motor will run forward 20 seconds. After that, it will stop 5 seconds and run reverse 20 seconds, right? Okay, stop. And then run reverse, right? And it will stop and run forward again. Yes, by itself. Okay, run forward again. So the time stop is very short, right? Only 5 seconds. Okay. So we can stop. This is just simulation. Yes, so we can stop the system. If we would like to start again, we can selection the mode and then we continue to start mode 1, mode 2 or mode 3 that we want. If we not select, it will show mode is not select and motor is stop. Yes. So this is just simulation. So let's go to create the logic step by step. Yes. So let me offline and then close the project and we will start from the first step by step. Okay. So I will close all the project. Okay, close all the project. Okay, and then we will create the new project. Yes, and then create the logic step by step, follow the command. Okay, so let's go to create the new project. Example, the project name is answer. I will create the empty project. Okay, and then I will add the target PLCs S3I. Okay, example answer. Yes, and we need to create the hardware, right? Hardware configuration. So the first one, I will replace the power supply module because I use PSD040. And for CPE, I will use slot 1. Yes. And we need to configure the Ethernet IP address, right? So the first one, I will configure this one to true. And then config. And the IP address will set 192.168.0.100 because the CPU is already setting. Yeah, we can ping 192.168.0.100. Okay, and for subnet mask 255.255.255.0. Okay, and the terminals, I will map the variable. Example, ETM CPE. Yes, and the array will be 60 bits for status address, right? Okay, for LAN 2 right now I don't use it, so no need to set anything. Okay, and then let's go to the CPE setting. The first one, we need to set the power up source, right? I will choose always plus, and the power mode I will choose run. Yes, and for the memory I will use 2048 first. Yes, the scan time I will use constant Windows. Yes, and no need to change anything, right? Okay, and then let's go to target and then put the IP address 192.168.0.100. Yes, and we can save the project and then download hardware configuration to the CPE. Okay. Oh, we need to stop the CPU, right? Because we changed the hardware configuration. Let me validate to check. Okay, no error, right? So we can download the hardware configuration to the CPE. Okay. Then we can start the CPU. Okay, successful start. Okay. So we can create the logic. Yes, follow the requirement, right? Okay. Let's go to offline and then go to create the logic, right? So the first one is we need to create the button for mode 1, mode 2 and mode 3, right? Or activate 1, activate 2 or activate 3. Then we will move, yes, okay. So let's go to the program blocks and I will create a new for later. Example, answer 1, yes. And then I will call main program, yes, call this one to main. Okay, like this. And then we can create the button for select the mode, right? Activate 1, 2, 3, right? So we can command activated selection 1, 2 and 3, right? So here we can use the counter app, yeah, for mode 1. Example, I use counter app. So app counter. Example, here is the button for mode selection, right? Example B PB mode selection, right? Okay, NO PB selection. Okay, view description variable mode, right? Or we can use none. Okay, like this. So PB selection, and this one I will use C up selection, right? Selection, yes. And here is button reset, so we can use NO PB reset or ST, right? And here we can set 4 for counter, yes, because we use mode 1, 2 and 3, right? So we can use 4 for this counter. Okay, I will adjust a little bit. Okay, enough. Okay, then I will use this one underscore CV, right, to compare with another logic, right? Okay, so if the counter is equal 1, yes, so I will write command a little bit. Example, activate 1, yes, activate 1 status. So I will use equal integer because counter is integer, right, for this one, yes. Then I will use the compare integer, yes. Can copy this one and paste. So if this one equal 1, I will got the output, right? Example, mode 1 active activated, yes, mode 1 activated. And for the mode 2 or activate 2, we can copy and then paste. Totally we have 3 modes, right? So example, mode 3 I can use this one again and compare with 2. Yeah, it means that mode 2, and this one should be changed to mode 2, right? And for mode 3, sorry, this one should be mode 2, activate 2. And for mode 3, I just right click and then copy and then paste here. Yes, and then change this one to mode 3 and compare with the 3, right? Okay, if the counter equal 3, then generate the output, yeah, for auxiliary. Yes, change this one to 3. Okay, we can change like this, easy to see. Yes, so right now the mode selection is already generated, so we can download and then test step by step. Yeah, so if I for this one one time, it means that press one time, it will activate the mode 1. Yes, so let's download and test. Okay, so if I push F12, yeah, it means that on. Let's see here, when the counter is equal 1 equal 1, and then the activate the lamp 1, yeah, for mode 1, right? Mode 2 and mode 3 is not activate. So if I push the push button again, equal 2, right? So activate 1 is false, and then enable the activate 2 is true, right? Activate 3 is not on. And if I push again, equal 3, the activate 3 will enable. Activate 1 and 2 signal is disabled, right? Okay, and then if I push the reset button, yeah, clear button, all activate signal is not true, right? Okay, so that okay. And we need to create, yeah, follow command, right? So activate 1 is the timer 10 seconds for forward, right? And stop 6 seconds, and for reverse is 10 seconds also, right? So we can command, yeah, example for timer for activate 1 setting, right? So if activate 1 is true, so I will use post contact. Yes, activate 1 here, right, is true, so we can copy and then paste here. So I will move timer, yes, timer example TMR second, yeah, because we use second, yeah. The motor will start 10 seconds, right? So I will use 10 seconds, yeah, for timer. But we can move the signal, right? Move the signal 10 seconds, 6 seconds, and 10 seconds to the timer, right? Okay. So here we have the timer, so we can move the signal first. So let's move integer. Sample move 10, yes, to timer 1, right? Okay, and also move integer, yes, to timer 2, right? move 6 seconds, right? 6 seconds. And we have timer 3 and 4 also, right? So move integer also. Okay. 10 seconds to timer 3, right? Okay. And one more. So move integer. Move 6 seconds to timer 4, right? Because we need to use the timer, yeah, here is also use timer 1, 2, 3 and 4, right? So for mode 1 is okay, yes. So we will create for mode 2 activate, right? Okay, so we can copy and then paste here and change this one to mode 2. So this one should be copied from here, right? Mode 2 activated. Okay. And then move, yeah, follow the requirement. 15 seconds, stop 7 seconds, and start 15 seconds, right? For mode 2. Okay. So 15 seconds to timer 1. 7 seconds to timer 2. And 15 seconds for timer 3. And move 7 seconds for timer 4, right? Okay. Here 15 and 7, right? 15 and 7. Sorry, 15 and 7. No, 20. Okay, 15. And for the mode 3, we do the same instruction. So we can copy and then paste. Change this one to mode 3. And then this one I will copy from mode 3, right? Okay, mode 3. And the timer we need to check with the requirement. Timer is 20 and 5, right? 20. So start 20 seconds. Stop 5 seconds, right? Start forward 20 seconds also. And stop 5 seconds. Okay. So mode 1, mode 2 and mode 3 we already created. Yes. So we need to create the logic for start and stop follow this mode, right? Okay. So let's go to new rank. So we can command create logic for start and stop the system, right? So the first one, if the mode 1 is activated or mode 2 activate, yes. So if mode 1, so we can write an O. Or we can choose the post context. For start, right? The first one is start, so the mode 1 is activate. Okay, we can use normal. open, yes. So mode 1 activated, right? So we can go to copy from this one. Mode 1 activate, or mode 2 activate, or mode 3 activate, right? So we can change this one to mode 2 and this one for mode 3, yes. And then ready to start the system, right? Okay. So we can use NO for start system. Start the system, right? Right. Okay, so we can create the button start and button stop, right? And see contact for stop. Stop system, right? Okay. Start system, stop system. And then the motor will start forward, right? If we push the start system. So the motor will start forward. Example, motor F. It means that motor start running forward. And I will hold the signal. So motor forward, right? Okay. And when the motor run forward 10 seconds, right? So we will use the timer 1. Yes, this one. So I will use timer sec. So when the motor is run forward, so TMR sec I will use like this. Yes, when the motor is run forward. So this one should be timer 1, right? Okay. From the setting, yeah, for mode 1 here. So example, I use timer 1 yes. Example timer 1. Yes. And then when the timer is activated, yes, I will use one contact, yeah. Example timer 1 Q. So when this one is on, yes, it will stop the system, right? Stop the motor. So I will use host contact timer 1 Q. Then I will lock, yes, the auxiliary 1, right? Example R1. It means that relay number 1 or auxiliary number 1. AUH1, yes. So this one should be hold the signal also, right? So AUH1 hold the signal. And then the motor will stop also, right? So I will stop the motor. So NC AUH1, right? And then the timer 2 will start on, right? For preset. Yes. So I will use one more timer, TMR6, right? Okay, TMR6 also, and I will use the same format. Okay, and then this one should be timer 2, right? From here. Yes, timer 2, 6 seconds, right? For mode 1. And then here I will use timer 22, timer 22 underscore CV, and I will use one auxiliary, example auxiliary 2, right? So when this one is turned on, yes, it will start the motor with reverse, right? After this one is turned on. So I will use post contact. Yes, and this one should be at auxiliary 2, right? AUH2 auxiliary 2. I will turn on the auxiliary 3, right? AUH3. Or we can turn on the motor with forward, right? Sorry, with reverse. So we can use motor as, yeah, motor underscore reverse, or we can copy from here and we can change this one to R. It means that motor run forward, sorry, reverse. And I can hold the signal also, right? So NO contact, and this one should be motor underscore R, right? Run reverse. And this one should be cut off the timer, right? So we can cut off here. NC contact and motor reverse here. And also interlock with forward and reverse, right? So we can use NC contact for motor as, and this one should be NC con for motor F, right? Should be interlock. It means that we cannot turn on this one the same time, right? Otherwise it will short the circuit. Yes. And after hold the signal, I will use one more timer for delay time running, right? So TMR6. Yes. So this one should be timer 3, right? Timer 3. So we can copy from here. Yes, for mode 1. So timer 3, and this one should be timer 3. Yeah. Timer 3 underscore CV, and this one should be coil and auxiliary 3, right? Okay, auxiliary 3. And then if this one is start, So for the solution, we can use one more timer for cycle, right? Automatic start forward, right? So we can use the post contact auxiliary 3, right? And then I will use coil for auxiliary 4. Okay, auxiliary 4. So when the motor run reverse 10 seconds, right? It will automatically stop. Yeah. Automatically stop, right? So this one should be cut off here. So NC con. And this one should be auxiliary 4, right? Okay, auxiliary 4. And then he will hold the signal here for auxiliary 4. Okay. And then I will use timer 4, right? Okay, so timer 4. TMR second. And we can copy from the mode 1, right? So mode 1, mode 2 and mode 3 is the same condition. So we no need to write the logic more. Okay. And this one should be a timer for 4. Timer for 4 underscore CV. And I will use one more coil. Yes. Example auxiliary 5. AUH5, right? And after AUH5 turn on, yes, AUH5, so NO, I will use post contact also. AUH5, it means that auxiliary 5 is turned on. I will use one more for recycle. Yeah, AUH recycle, it means that to start the first step, right? So recycle, yes. And then I will hold the signal also. So AUH recycle. And then I will stop this one also. So NC contact, sorry, NC contact for AUH recycle, right? Yes. And then it will start the first step, right? So start the first step here. Yes. So parallel with here. And O contact for step 1. Yes. And then if the forward is start, this one should be interlock, right? So NC contact M motor forward, yes. Okay. And then if we push the button stop, it will stop all, right? Okay, so we can copy and then paste for all the rank, right? It is the safety. Okay, stop all. So the activate 1, 2, 3 should be have all the network, right? So we can use NO contact for activate all. Example, NO activate mode activate 1. Yes, mode 1 activate. NO mode 2 activate, and mode 3. Yes, so NO mode 3 activate, right? And this rank is also set. Yeah, so if no mode 1, mode 2 and mode 3 is activated, we cannot start the system, right? Okay, so we can put more mode 1 activated, mode 2 activated, and mode 3 activated, right? Okay, and this one also. Actually we can copy, so we can copy and then paste, right? Because it should be activated. Okay, so we can test. So that's all for this program. So if we push F2, mode 2, it will move this setting to timer 1, 2 and 3. Yes, so it will follow our operation. For mode 3 also move 20 second, 5 second, 20 second and 5 second to timer 1, 2, 3 and 4. Yeah, so that's all. So we can connect and then download the logic to the CPU. Okay, then we can test, right? So right now no mode 1 and 2 is activated, right? Because 0, the counter is stay 0, right? So if I push F12 for enable the mode 1, yeah, let's see, mode 1 here is turned on, and then it will move the setting 1, yeah, 10 second, 6 second, 10 second and 6 second to timer 1, 2, 3 and 4, right? So mode 2 and mode 3 is not activated, right? And the condition is ready to start here. Yes, so if I push start, okay, I will push F12 for start the system. Yes, let's see, the system is start activate and running forward signal, right? Okay, after that stop, right? Stop 6 seconds here, run reverse, right? After 10 seconds it will stop the system again, right? Okay, stop the system 6 seconds. It will recycle to start the motor forward again, right? Here motor is run forward again. Yes, if we would like to monitor, we can monitor also. Let me watch the signal. Yes, reverse and forward, right? Okay, let's go to utility and then go to voice and we can drag and drop the signal, yeah, and then we can see. I will change the property to be sample 100 second, yeah. Let's see, the signal is the red one is the forward and the blue one is reverse. Okay, so automatically, okay, it will start forward, right? Okay, forward 10 seconds. It will stop, right? After that it will start reverse. Yes, start reverse. After that it will stop, right? So if we would like to change the mode, yeah, I can push stop for change the mode. So let's go to the stop system here. So if I push stop F12, all the system is stop, right? Stop all. So it will 0, yeah. Yes, stop. And if we would like to change to mode 2, we can go to mode 2, right? Okay, I will enable the counter to mode 2. Yeah, this one. I will push on and off, yeah. So mode 2 activated right here. And then move the timer. Yeah, let's see, mode 2 is turned on. Then this one equal 15, 7 sec, and 15 second and 7 second, right? And then we can start again. So start. The system will run also, right? Okay, start forward. 15 seconds. Okay, and then stop. 7 seconds. And it will start reverse. Yeah. After 15 seconds, it will stop again, right? Stop again. Okay. And after 7 seconds, it will start forward again, right? Automatically stop and start, reverse and forward. Okay. Okay. It will stop and then start reverse again, right? Follow the timer that we already setting. Yes. So if we would like to change to mode 3, okay, we can stop the system, yeah. And then let's change to mode 3, right? For counter, I will change to mode 3, yeah. So equal 3, the mode 3 will activate it, yes. And then move the timer of mode 3, yeah. 20 seconds, 5 seconds, yeah. Follow the step, yeah. 20 seconds, 5 seconds, and 20, yes. Follow this step. And then we can start the system, right? And to see the signal together. So if I push start the system, yeah, the motor will run forward. Yes. After 20 seconds, it will stop, right? It will stop automatically stop. Yes. And after 5 seconds, it will start reverse, right? 20 seconds, it will stop again. Yes. Let's see, the signal will be stopped again. Okay, stop. and then after 5 seconds it will start again for avert signal. Yeah, 5 seconds. And if we see the signal, we can change this one to example like this. Yeah. So let's see, the mode is not the same, right? The timer is not the same for mode 1, mode 2 and mode 3. Follow our requirement. Yes. And then we can go to create the HMI for start and stop and see the stator, right? So we can go to outline. So the first one, I need to use the %m for the selection, right? Example %m1, %m2 for reset, right? %m2 for reset, and okay. And for start and stop, we also show the signal. Okay. For activate, I will use %m also for show the activate 1, 2, 3 on the HMI. %m4, %m5, and also start and stop, right? Start the system. %m6, stop the system. %m7, right? Okay. And if we would like to show the timer 1, 2, 3, we can also show the status of timer, right? Example, timer 1, I can use %r. Timer 2, %r also. Timer 3, %r also. And timer 4, %r also. Yes. Okay. Then we can download again. Okay, download again. Okay. And I will clear the counter. Yes. 20. And we need to create the HMI for start and stop and see the signal selection from the HMI, right? So let's go to Workbench. Create the new project. Example, this one for username and password, right? I will use administrator. Password, right? We can put another password that we want. Okay. And we can put the project name, example answer. Answer project. So the first we can choose the driver, right? Protocol. I will use this driver. And then go to the project property, right? And go to the port. I will create the one port by use the driver. Yes, this driver. Okay. And then I will choose the device. example device PLC 1, and this is the IP address of Ethernet module right here. Yes, 192.168.0.100. It is the target IP address, right? So 192.168.0.100. Okay. And then we can start the project. Yes. We can start the project to check the device is linked up or not. Okay. Right now the device is up. It means that okay. So we can dynamic and then create the point, right? The first one is selection button, right? So example PB selection. So we can write new and then PB selection. I will use the boolean and device is PLC1 that we already created. And here we can use the %M1, yes, here. So %M1. Okay. And for PB reset, yeah, for reset the counter or clear the selection, right? So we can duplicate from here. PB clear or PB reset. PB clear, yes. We use the %M2, right? Here, %M2. Sorry. Yes, %M2. And for the activate mode 1, 2, 3, yes, we can also create the point. Example activated 1. We use %M3, right? Okay, M3. Yes. And then activate 2 and 3, we use M4, M5, yes. So activation M2, we use M4. And activated 3, we use M5. Sorry, activated 3. We use %M5, right? Okay. And for start and stop, let's scroll down a bit. Start and stop the system, right? For start, we use %M6. Okay. So we can duplicate for start system, right? %M6. And one more for stop the system, right? %M7. Yes. And we need to show the timer on the HMI also, right? For timer 1 status, timer 2 status, timer 3 status, and timer 4 status, right? So we can use %R1 for timer 1. So example timer 1. So I will use analog and device also. And it is the integer, right? So integer %R1, this one %R1, yes. And for timer 22 we can also duplicate for timer 22 and %R2, yes, this one, yeah, this one. And for timer 33 we can use %R3. And for timer 44 %R4, yes. And let's check the point by right click and then check the control, yes, here. So right now all text is false, yes. So we can create the screen for control, right? So right click, new screen. Yes. And the first one we need to choose the motor, right? Or asynchronous motor. Let's go to Object Explorer and then insert one motor, example this motor, yes. Yes. I will adjust the geometry to be 300, yes. Okay, like this. And we need to choose the button, right? For select the mode and clear the mode and start and stop, right? So let's go to button. Example start. I will change to black for text and button will be blue, right? Okay, for start. And one more for stop. Can change the text to stop. And I will change to the red color. Okay. Like this. And we need to copy. Yeah, we have button for select, yes, mode selection, right? Yes, mode selection. And this is a clear selection or clear mode, right? Okay. Okay, like this. And we need to create the button, right? Okay, configure the button. The first one is start, right? So start. So go to event and then go to the mouse up, right? New procedure. And then absolute set point for button start, right? The first one is PB start. Or start system, right? Set point to 1, sorry, set point to 0. Okay, and we can create the new procedure for mouse down. And then choose the absolute set point and then choose the point, router point for start, right? Start system. And then set the value to 1, right? For mouse down. Okay. And for the stop button, we do the same. Yeah, make the same procedure. Go to mount up, and then choose the new procedure, new and absolute set point, and then browse the point. Yeah, so we can choose stop system, set value to 0, and create the new procedure for mount up. Mount down. Create the new procedure, absolute set point, the stop system, right? Set point to 1. Okay. And we need to choose the selection, right? Okay, the selection mode. So we can go to event and then choose the mount up, choose the new procedure, new and absolute set point. So it is the mode selection, right? So browse, active 1, right? Let me check the point. Is timer okay, clear. PB selection, right? Okay, PB selection. So PB start. Okay, PB selection, and we can copy, set the value to 0, right? And we can create a new event for mount down. Choose the new procedure, create a new absolute set point. We can paste and set value to 1, right? Okay. And for clear mode, we can change the color to be another color. Example, this color, and this one should be this color. Example, yellow color. Yes. And for clear mode, we do the same procedure. Go to mount up, choose the new procedure, absolute set point, and then browse the point to be PB clear, right? And then we can copy, set the value to 0, and then choose one more for mount down. Choose the new procedure, absolute set point, paste and set value to 1, right? Okay. And then we need to show the signal of the motor also, right? When we push start. Okay. So the signal of motor, we can use the rectangle. Yeah, example, this motor. I will change the color. If forward is the green color, right? So go to color animation and then choose the text, motor, right? We can start, browse again, and then browse. Let's see the text again. Oh, signal the motor, right? Forward and reverse, not yet create the text, right? So let's check again. We need to put the %M also, right? To show the signal on HMI. So let's put %M 8 forward and %M9 for reverse, right? And then we can download again. Actually, for this one, we can put %Q. Yeah, example, I put %Q. Okay, we can put %Q because we need output to the control the relay or contactor, right? So I will put %Q1 and %Q2 for reverse and forward, right? And then we can download again. So %Q1 is command for start forward, and %Q2 is command for start reverse. Okay, so let's download again. Okay, and then we will create the one more text, right? So example, motor F, it means that start forward. So %Q1 and one signal, motor reverse, right? So %Q2, yes, %Q2, and then we can design the screen. Yeah, continue to design the screen. So we will got forwards, and then I will change the field to be solid, and then choose the green color forward, and duplicate one more for reverse. I will change to the I will change to this color. And when the motor is not run, yeah, it will red color, right? Okay. And we need to show the status of take also. Example, motor is running forward or running reverse. Yeah. So we can use the text string. Yeah. I will change the color to be yes, red color. So if motor is run forward, so go to color animation, and then choose the expression. So browse the point for motor forward. Yeah. I will translate the text to be running forward. Yes. And change the color to be go to field, right? I will change to the green color also. Yes. And one more for reverse signal, so we can duplicate and change to the reverse. Yes, running reverse. And I will change color to be this color. And if motor is not run forward and reverse, yes, so we'll duplicate. So not motor run reverse and not motor forward. Then I will show stop, right? Then choose the red color. Yes. Okay. So if we run the screen, we will got the motor is stopped, right? Let me check again. Motor and not, right? Okay, and not motor run forward. It should be show stop. Okay, right now show stop, right? So let's test together. Okay. So when I push the button, yeah, let's push the button to be select the mode, right? When I push selection to be select, let's see, it is the mode 1, right? So we need to show the mode 1, mode 2 or mode 3 here also, okay? So let's go to edit more. Actually we can copy this text and change the color to be another color that we want. Example, I will change to use the yellow color, and then change the text, right? Example, I will delete all this text first, yeah, and then choose the new. The new expression should be browser point that we already created mode, right? Active mode 1 and 2 and 3. So if mode 1, I will translate the text to be mode 1 selected, yeah, or mode 1 activated. Okay, mode 1 activated. And when select to mode 2, yeah, I will change to mode 2 activated. And when change to mode 3, I will show the signal mode 3 activated. And if the mode 1 and mode 2 and mode 3, yeah, so if not activate 1 and not activate 2, yes, not activate 2 and not activate 3, right? I will change the text to be mode doesn't select. Okay, mode doesn't select. Okay, so we can test. Okay, right now it show mode 1 selected, right here. So I will adjust the text alignment to be center, and for the font I will increase to be 16, yes. Okay, let's test again. So right now the mode 1 is selected, right? So if I would like to select the mode 2, yes, mode 2, it will change to mode 2 selected, activated, mode 3 activated. And when we select until mode 3, so we need to hit then this button, right? Because we don't have the mode 4. So if mode 3 is selected, okay, here we can hit then the button. So mode 3 selected, okay, can browse the point to be mode 3 or activation mode 3 is selected. So we can hit done, right? Okay, mode 3 is selected, we can hit done. If we would like to please change the mode, we need to clear the mode first, right? Clear the mode. It will mode doesn't select, okay? So we can test for mode 1. So if I push select mode 1, the system is ready to start, right? And if I push the start button, the motor will running forward, yeah. Let's see, running forward. After that, it will stop, right? Automatically stop. And run the reverse, right? Okay, motor is run reverse. And if we would like to see the timer, let's see here. Yes. The timer is not the same, right? Start and stop for mode 1. Yes. Okay. Start and stop forward. Yes. Forward and reverse automatically. Yes. Okay. If we would like to change the mode 2, we can also stop. Yeah. Stop, the system will be stopped. Yes. And we can change to mode 2. Yeah. And then start again. Yeah. So motor will running the forward again. Yes. And it will stop and then run the reverse. Follow our requirement. Yeah. Motor stop. After that, it will run reverse, right? Okay. Running reverse. After that, it will stop, right? Follow a timer that we already setting on the logic. Okay, and it will start forward again. Yeah. So if we would like to stop, we can also pre-stop to change the mode. I will change to mode 3, and then this button is hidden. Yeah, no need to change anything. So we can start. Yeah. The motor will run forward. Yes. After that, it will stop and run the reverse. Yes. It will stop. 20 seconds, right? The last activate for mode 3. Yeah. It will stop only 5 seconds. Okay. And run reverse, right? Run reverse. Okay. After that, it will stop, right? 20 seconds, it will stop. So stop. And then run again. After 5 seconds, run forward again. And the program will cycle automatically. Yes. If we would like to change the mode, we will stop the system and then clear the mode. And if we would like to run the mode 2, we can also press 1, press 2, and we can start the mode number 2. Yes. Mode number 2. We can control everything that we want. Yes. Follow this configuration and setting. Yes. So I hope this program is helpful for the commander that command me on the previous video, and thank you very much for command this video also. And for this time, I would like to say thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.